డాక్టర్ ఇలాంటి అడ్మిట్ చేయండి.
Raghavan. Now I request all the dignitaries to the kindly join hands for the lamp lighting ceremony, making the official inauguration of this event and wishing for a successful program ahead. I request all to stand for the national song. Dr. A.V. Girdhar Rao Garu will now provide an overview of the course.
Hello. Respected distinguished dignitaries, Director NIT Varangal, Professor Vidyadhar Subudhi garu, respected Dean International Relations Alumni Affairs, Professor S. Srinivas Rao garu, respected Electrical Engineering Department HOD, Professor N.V. Srikanth garu, and the participants, faculties, as well as research scholars, PG students, a warm welcome and very good morning to you all for this a 5-day GIAN course on non-invasive fault diagnosis of propulsion motors used in electric vehicles. So in this course, it is designed to cover topics related to non-invasive condition monitoring and fault diagnosis of propulsion motors used in electric vehicles. Electric vehicle user base is growing with increase in recharging infrastructure and improved battery technology. There is a distinct possibility that EV will become prevalent within the next decade. Propulsion motor is a critical component of EV. Any unexpected failure of propulsion motor would have significant consequences. Therefore, there is a definite need for a technology that would detect faults in propulsion motor at an incipient stage. So in this course, the attendees will be introduced to eccentricity faults, the conventional approaches to detect them, and their limitations. The participants will then be familiarized with machine learning based approaches to detect eccentricity fault of varying severities using motors line current data. The course is planned to be offered for 1 credit and the course duration will be of 5 working days. Various aspects of the subject will be covered as part of the course with a proper blend of theory, simulation, and experimentation. So course participants will learn these topics through lectures, hands-on experiments, also case studies and assignments will be shared to stimulate research motivation of participants. So some various institutes the participants came, faculty, research scholars, PG students. So from SRM University, Amrita Vishwa Vidyapeeth, IIT Jodhpur, NIT Rourkela, other NIT. So I think with the interaction with the expert lecture by the Professor T. Ilampati, professor from the University of Victoria, Canada. So immense knowledge and interactions will be done with various diversified institutes and faculties, scholars, as well as PG students. So some good learning will be comes to the success of this GIAN course. Thank you all.
Thank you, sir. Our beloved director, Professor Vidyadhar Subudhi garu, will now address the gathering and share his insights.
A very good morning to all, and on behalf of NIT Varangal and Department of Electrical Engineering in particular, and on behalf of the coordinators, Professor Giridhar and Professor Narasimha, I extend a very, very warm welcome to all the participants to this 5-day GIAN program on very interesting topic, that is non-invasive fault diagnosis of propulsion motors using electric vehicle. So I also heartily welcome Professor P. Ilampati from University of Victoria, Canada, to deliver his expertise and to disseminate the experience on this very interesting topic. At the same time, I congratulate both the coordinators and the department, including the head of department, Professor GIAN, for this endeavor. My special thanks goes to Professor Srinivas, our Dean, International Relations and Alumni Affairs, who is channelizing the GIAN program at our institute. And I believe the participants from different parts of this country, NITs and SRM and other institutes of prestige, joined here to learn this advanced topic to be deliberated by this foreign expert and also internal experts in the campus. I urge the participants not only to be in the classroom but also spend some time in the laboratory and also would have an opportunity to see the places of both visiting in and around Bangalore. So it is definitely true that we are progressing to a more accomplished lifestyle and very efficient way of using our computation, so that the carbon footprint will bring down to the lowest extent possible, so that the environment will remain very, very healthy and effective for the human being to lead a very, very healthy life. So therefore, the endeavor towards adopting electric vehicles sooner or later will be more feasible through the pioneering efforts of the electrical engineering technology. In particular, the motors that will be more useful in electric vehicle applications, apart from the power converters and the renewables. So therefore, our Department of Electrical Engineering is very, very active in this smart grid and electric vehicle technology. I'm glad that we are fortunate to be associated with Hitachi EML, who contributed towards propagating all the benefit of offering the smart grid MTech program and developing a lab in the institute. I will definitely believe the coordinator should have arranged a visit of the participant to this lab. So I wish this 5-day GIAN program at our institute will be very, very meaningful and fruitful to all the delegates, all the participants. And I also wish you very, very happy and enjoy to stay in the campus. And once again, before I close, I take this opportunity to thank all the volunteers and all faculty members and the coordinators of this Department of Electrical Engineering to make it a great success. And I wish this GIAN program a grand success to me in the campus. Thank you very much.
Thank you, sir, for your valuable insights. Professor N.V. Srikanth Garu will present an overview of the Department of Electrical Engineering.
Respected dignitaries on the dais, Professor Illampariti, Assistant Teaching Professor, Electrical and Computer Engineering, University of Victoria, Canada. Respected our beloved Director Sir, Professor Brijadhar Subuddhi, Professor S. Srinivas Rao, Dean, International Relations and Alumni Affairs, my colleagues, participants, ladies and gentlemen. A very good morning to all of you. It's my privilege to introduce about our department to you all on this inaugural function of this 5-day GIAN course on non-invasive fault diagnosis of propulsion motors used in electric vehicles. The Department of Electrical Engineering is one of the oldest departments of The then REC Warangal, now it is National Institute of Technology Warangal. It was established as one of the major departments of the institute. Since its inception in 1959, the Department of Electrical Engineering has been actively engaged in teaching and research and in diverse fields of electrical engineering. At present, 32 faculty members are working in the department. Faculty having expertise in various fields of electrical engineering such as power systems, powertronic converters, drive systems, smart electric grid, control and automation, control of special machines, renewable energy systems, converters for LED lighting systems, multi-level inverters for open and winding induction motors, applications of powertronics to power quality improvement and industrial drives, hybrid energy storage systems, DSP control drives, power system transients, power quality, EMTP applications in power systems, AI applications into power engineering, etc. The Department of Electrical Engineering offers BTech in Electrical and Electronics Engineering, MTech in Powertronics and Drives, Power Systems Engineering, Smart Electric Grid, and MTech in Control and Automation just started from this academic year onwards, and PhD in all the major fields of electrical engineering. Self-finance programs in MTech PG Diploma and PhD have been started from the academic year 2021-22. At present, around 136 students are admitted through JEE in BTech, around 100 students through GATE in MTech programs. At present, 100 research scholars are working towards their PhD degree in our department. And we also have many research projects funded and sponsored by various agencies like MOU, MHRD, Imprint, Spark, DST, SERP, CPRI, and they have been executed for a tune of 650 lakhs. Very recently, we had DST FIST project cost more than 1 crore is sanctioned to the department. At present, around 9 to 10 research scholars are working for their executions of these projects. Department has state-of-art equipment such as programmable DC supplies, programmable solar simulators, high-end mixed signal oscilloscopes, digital storage oscilloscopes, multi-level inverters, lab view software and hardware development kits, digital signal processor systems, hardware in loops, OPLRT, rapid prototyping systems, DSpace, and we also have a full-fledged equipped smart electric grid lab sponsored by Hitachi Energy India Limited. We also have grants released through MHRD, TechUp, and various sponsored research projects towards establishment of various labs and state-of-art equipment in our department. The department has a strong industry interaction and has been involved in constantly handling various consultancy projects for various industries and lift irrigation projects of Government of Telangana and Andhra Pradesh. Department has an MOU with Central Power Research Institute, Bangalore, ABB Power Product Systems India Limited, Bangalore, Power Grid Corporation of India Limited, Power System Operation Corporation, POSACO, now known as Grid India, and we have a strong MOU with Hitachi Energy India Limited also. We also have student exchange programs with various IITs like IIT Delhi, etc. Student support activities. We also have student support activities to our department known as Electrical Engineering Society, technical support through IEEE student branch, and Women in Engineering student mentorship, industry visits, industry lecture series through Electrical Engineering Society, and in curriculum related courses. We also have outreach activities like prestigious faculty development and training programs have been sanctioned to the department, sponsored by Government of India under various prestigious schemes, namely like GIAN, Atal, Spark, E&ICT, MITI, TLC, NIT, Pandit Madan Mohan Malaviya National Mission on Teachers and Training, CEP, NITW, and self-finance short-term training programs by the faculty of the department, through which our department faculty are contributing to improve technical education in various domains of electrical engineering community in the region and across the country as well. Apart from this, the department faculty are actively contributing towards various academic and research activities to community of technical education. We also have placement record errors, crossing 95% for all in our BTech program, and our Smart Electric Grid program is going on very well. It is also crossing our placement record more than 90%. Now, the department also have produced various alumni in occupying various helm of affairs in Indian Administrative Services, IES, and they are also working as CEOs of multinational companies. With this brief record of our department, I welcome you all to this GIAN course on non-invasive fault diagnosis of propulsion motors used in electric vehicles. Thank you all. Thank you, Ananda. Thank you.
Thank you, sir. Now I request Professor S. Srinivas Rao Garu will address the gathering.
Good morning to all. Respected Director Professor Vidyadhar Subodhi, Foreign Expert Professor T. Ilamparthi, Electrical and Computer Engineering, University of Victoria, Canada, Head of the Department Professor N.V. Srikanth, Course Coordinators Professor A.V. Giridhar and Professor B.L. Narasimharaju, dear participants, research scholars, faculty members of the Department of Electrical Engineering, and the participants who are attending this program through virtual mode. Very good morning to all and welcome to this 5-day course on non-invasive fault diagnosis of propulsion motors used in electric vehicles. So myself, I am S. Srinivas Rao, Professor in Department of Electrical Engineering and holding an additional responsibility of Dean International Relations and Alumni Affairs. Our Dean Office looks after the alumni relations and also international activities. With reference to the international activities, this office is associated with this GIAN Global Initiative for Academic Networks, Spark Program Scheme for Promotion of Academic and Research Collaboration, UK India Education Research Initiative, Heritage, BRICS, DAD, MITAX, and etc. Along with these programs, NIT Warangal is working sincerely for availing all possible collaborations with various international universities and institutions for collaborative research, faculty exchange programs, students exchange programs, under the constant and continuous directions and encouragement from our esteemed director, Professor Vidyadhar Subodhi. So regarding this GIAN course, the Government of India initiated this global initiative for academic networks in 2015 in higher education institutions aimed at tapping the talent pool of scientists and entrepreneurs internationally to encourage their engagement with the Institute of Higher Education in India, so as to augment the country's existing academic resources, accelerate the pace of quality reforms, and elevate India's scientific and technological capacity to global excellence. So the proposed objectives of this GIAN are to increase the footfalls of reputed international faculty in the Indian academic institutes, provide opportunity to Indian faculty to learn and share knowledge and teaching skills in cutting-edge technologies, to provide opportunity for Indian students to seek knowledge and experience from reputed international faculty, to increase the avenue for possible collaborative research with international faculty, to increase the participation and presence of international students in the academic institutions in India, opportunity for the students of different institutes and universities to interact and learn subjects in the most advanced areas through collaborative learning process, and provide opportunity for technical persons from Indian industry to improve understandings and update their knowledge in relevant areas, motivate the best international experts in the world to work on problems related to India, develop high quality course material in advanced areas in the form of video recording and live webcast so that it can be used by a large body of faculty and students throughout the world, to document and develop new pedagogical methods in emerging topics of national and international interest. So with these objectives, GIAN was initiated in 2015 by Ministry of Human Resources Development. Now it is called Ministry of Education. NIT Warangal has successfully completed GIAN Phase 1, Phase 2, Phase 3 programs. Now Phase 4 program is running. In Phase 1 program in 2015-16, 27 courses were sanctioned with a budget of 1.87 crores. In 2017-18 in GIAN Phase 2, 41 courses were sanctioned with a budget of 2.48 crores. In 2019-23, 21 courses were sanctioned under GIAN Phase 3 with a budget of 1.41 crores. In 2020-24-25, till now, 24 courses were sanctioned with a budget of 1.75 crores, and few courses are under review. Now, under this GIAN Phase 4, Electrical Engineering Department got 7 courses, Electronics and Communication Engineering 6, Mechanical Engineering Department 4, Civil Engineering Department 4, Computer Science and Engineering 1, Mathematics 1, Physics Department 1. So our special thanks to Director IIT Hyderabad and National Coordinator of GIAN, Dr. Anil Agarwal and his team at Hyderabad for closely monitoring the activities related to this GIAN course, and also speeding up of the process of reviewing the course proposals and regularly monitoring the progress of these activities, and also along with the academics as well as financial activities are closely monitored from IIT Hyderabad national coordinator. In this GIAN Phase 4, it is mandatory for video recording and also live webcast so that it can be used by a large body of the students and faculty throughout the world. In this GIAN Phase 4, till now 24 courses were sanctioned. This is the 15th course we are running. Remaining 4 courses are yet to be completed before April-May. In all 4 phases, total courses sanctioned to each department are Civil Engineering Department 28, Mechanical Engineering Department 17, Chemical Engineering 14, Electrical Engineering Department 13, Electronics and Communication Engineering Department 12, Mathematics 7, Computer Science Engineering 7, Chemistry 3, Metallurgy and Materials Engineering 2, Physics 3. A total of 106 courses were associated with this GIAN all 4 phases. The total number of 48 foreign faculty are collaborated with NIT Warangal under GIAN course from different countries like UK, USA, Australia, Belgium, Israel, Canada, Singapore, Germany, Italy, Japan, Malaysia, Europe, Norway, Portugal, Romania, Russia, Slovakia, Sweden, Taiwan, Greece, Denmark, France, England, Scotland, Finland, Trinidad and Tobago, and Middle East. In the recent past, many foreign experts or faculty members from various institutions and universities have delivered lectures at NIT Warangal, and a lot of faculty members, research scholars and participants attended for various programs have benefited a lot by listening to the foreign faculties, so that research collaboration as well as knowledge exchange may further and further improve for this type of programs. We are very much thankful to Government of India for sanctioning this 24 courses under Phase 4 to NIT Warangal. So recent past, the following faculty members have visited our NIT Warangal and delivered lectures. Some are stayed for 2 weeks and some programs for 1 week. So these people are Professor Rahul Rai from Department of Automotive Engineering, Clemson University, USA, Professor Alfred Kalyanapu, University of Tennessee, USA, Professor Tanya Datta, University of Tennessee, USA, Professor John Shevard, University of Tennessee, USA, Professor Vijay Raghavan, McGill University, Canada, Professor Maxim Shatov, University of Cytology of Russian Academy of Sciences, Professor Shrikant Joshi, University of West Sweden, Professor Jannapat Paniswas, Queen Mary University, London, Professor Indrajit Chaube, University of Connecticut, USA, Professor Tarun Ratnaraj, University of Edinburgh, USA, Professor GIAN, School of Electrical and Electronics Engineering, National Nanyang Technological University, Singapore, Professor Rahul Jain, National University of Singapore, Professor Ranjit K. Soman, Delft University, Netherlands, Professor Leon, University of Twente, Netherlands, Professor Israel Cohen, Technion University, Israel, Professor Rukmi Datta, University of New South Wales, Sydney, Australia, Professor Yao Ming Chen, National University of Taiwan, Professor Jim Ching John, Department of Electrical Engineering, National Taiwan University, Professor Suresh Gade, University of Ottawa, Canada, Professor Henrik Leon, Chemistry and Chemical Engineering Department, Clemson University, Sweden, Professor Alexei, Department of Technology and Society, Lund University, Sweden, Professor Carmelo, Department of Technology and Society, Lund University, Sweden, Professor Muhammad LCC, National Kaush Wing University of Science and Technology, Taiwan, Professor Bhaskar Chaube, Institute of Analog Circuits and Image Sensing, CGEN, Germany, Professor Edris, Department of Electrical Engineering and Automation, Aalto University, Finland. So all these people have delivered lectures in 5-day and 10-day programs. So many participants and faculty members have benefited a lot by listening to them. Regarding this course, non-invasive fault diagnosis of propulsion motors used in electric vehicles. Now it is an order of the day to opt to urban, particularly for urban mobility electric vehicles. For highway transportation, these hybrid electric vehicles are becoming popular. So these hybrid electric vehicles, particularly the energy storage systems, makes a lot of impact on this operation of these electric vehicles. But urban mobility, maximum distance travel is 30 to 35 kilometers in one direction. Because of those reasons, electric vehicles are becoming very much popular, and charging infrastructure is also at home or offices also there is a possibility of charging the electric vehicles, which can run continuously for 35 to 40 kilometers. As a result, electric vehicles are entering in the almost major cities throughout the world in urban mobility system. For this, we all know that electric motor plays a major role. For that, power electronic converter is required to feed the motor. So in this course, fault diagnosis of propulsion motor used in electric vehicles will be discussed. I hope along with fault diagnosis, fault tolerant techniques also may be discussed, so that motor works satisfactorily without any trouble for its lifetime, and some restrictions will be there on the energy storage side. So I once again welcome and thank Professor T. Ilamparithi for accepting the proposal submitted by Professor Giridhar and Professor B.L. Narasimharajulu, and it got scrutinized at national level, and course was sanctioned, and all the way from Canada he came to deliver the lecture, so that all participants who are physically attending and participants who are registered and virtually attending, and the participants who are directly using this web link for enhancing their knowledge. Wish you all the best to all of you. Thank you one and all.
Thank you, sir, for your valuable insight. Professor V.L. Narasimharaju garu joined virtually. Thank you for your presence, sir. Now I request Jayashree, research scholar, will introduce the Dr. Ilamparithi.
A very good morning to everyone. It is my pleasure to introduce Dr. Ilamparithi garu. Dr. Ilamparithi garu graduated with an electrical and electronics engineering degree from Anna University, India in 2005. Intrigued by the field, he pursued his masters in power electronics, machines and drives from the IIT Delhi from 2005 to 2007. Then he completed his doctoral degree in the field of condition monitoring of electrical motors from the University of Victoria, British Columbia, Canada. Upon completing his PhD in 2012, he worked in industry for 4 years. His professional experience relates to hardware in loop simulation studies of electrical grids and motor drives. In 2017, he returned to his alma mater, the University of Victoria, British Columbia, Canada, as an educator. In his role as an assistant teaching professor, he has been instructing courses pertaining to electrical power specialization, as well as in the introductory electrical and computer engineering design. As a teacher, Dr. Ilamparithi garu instructs more than 600 students a year and has won the Best Teacher Award in 2021. Besides his teaching, Dr. Ilamparithi garu has been conducting cutting-edge research in the domain of electric vehicles. His major research focus lies on the non-invasive detection of motor faults used in electric propulsion applications. In addition, he carries research activities pertinent to electrical vehicle charging, both wired and wireless. To carry out these research initiatives, he has secured funding of more than 300,000 Canadian dollars through his research. He has more than 20 IEEE publications. Also, he has co-supervised 8 graduate students. Dr. Illamparthi Garu, he is also an active member of the IEEE. He was the chair of the IEEE Victoria section, Region 7 from 2023 to 2025. During his tenure, he was a part of the team that successfully organized as an international conference, IEEE PACRIM 2024. Currently, he is an active in organizing another conference, IEEE CCCE 2025, that will happen in Vancouver in May 2025. Thank you, sir.
Thank you, madam. Now I request Dr. T. Illamparthi will provide insights into the course.
Good morning, Honorable Director, respected Dean, International Relations and Alumni Affairs, respected Head of the Department, Electrical Engineering, my beloved host faculty members, Professor Narasimha Raju sir and Dr. Giridhar sir, distinguished guests that are attending in person, participants, and also participants that are attending remotely. A very good morning to one and all. First, I would like to convey my sincere thanks to the host faculty members and to Professor Srinivasa Rao sir for organizing this GIAN course on an important topic, in my opinion, which is non-invasive fault diagnosis of propulsion motors. It is my absolute privilege to be part of this GIAN course and to be able to deliver this 5-day workshop. In this course, as a team, we have carefully curated contents in such a way that participants will learn 3 decades of research over 5 days. So you're going to acquire 30 years of research knowledge in 5 days. So it's going to be intense. At the same time, I hope you will all enjoy and learn a lot. The main intention or the structure of the course is to introduce you to the fundamentals of some of the faults that happen in electric motors. In particular, we will be focusing on air gap eccentricity faults. And then I will introduce you to traditional fault diagnosis techniques, some of the challenges and limitations associated with them. Following that, I will introduce you to some of the modern data-based fault diagnostic techniques. Again, there are challenges with these newer techniques, so we will learn about them. And throughout this workshop, you will be given hands-on opportunities to practice what you learned in the theory part of the course. Okay? So by the end of this course, you will have a good enough familiarity with the topic that you will be able to pursue research in this domain once you return to your host institutions. And that is the goal of this workshop, to enlighten you all about this topic and let you pursue active research in this field, because as Professor Srinivasa Rao sir mentioned, electric vehicles are becoming more and more prominent, and therefore it's imperative that we have a lot more research in this domain. Okay? So with this, I will stop at this point, and then I'm looking forward to the course. Thank you so much.
Thank you, sir. I kindly request for all the dignitaries and faculty members to facilitate Dr. Illamparthi Garu. I kindly request for all the dignitaries and faculty members to felicitate Dr. Ilamparthi garu. Vote of thanks. I now invite Dr. A.V. Girdhar garu to deliver the vote of thanks.
It's a privilege for me to express vote of thanks for this occasion of a 5-day GIAN course on non-invasive fault diagnosis of propulsion motors used in electric vehicles during 17th February to 21st February, organized by Department of Electrical Engineering, NIT Warangal. And we are very thankful for our beloved director, Professor Vidyadhar Subudhi garu, for having a vision to uplift our institute in different dimensions, and also encouraging all in engineering and technological research activities. We are very thankful for our Dean, International Relations and Alumni Affair, and also local coordinator GIAN program of our institute, Professor S. Srinivas Rao garu, encouraging us to do these activities as well as giving good guidelines throughout this course and support. We are thankful for our department head electrical engineering, Professor N.V. Srikant Rao sir, so providing encouraging and support and giving guidance in doing this course throughout this duration. We are very thankful for our resource expert of this GIAN program, Professor T. Ilamparthi garu, so electrical and computer engineering, University of Victoria, Canada, coming all over to give his valuable having good knowledge in this area and sharing with us and challenges in this area to get better benefit of all. So we are very thankful, sir. We are thankful for the professor in charge guest house providing necessary facilities for the international experts as well as participants and also staff of the guest house. And we are thankful for professor in charge seminar hall complex providing the good arrangements for Professor Anjaneyal sir and also their office staff. We are thankful for the GIAN office having good support for us in this GIAN course. We are thankful for the live recording and photography, live telecast persons for their support in this course. and also thankful for food arrangement people who in this course. Thank you one and all. Thank you.
Thank you, sir. I request everyone to please stand for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
I kindly request everyone to join for the group photo.
వీడియో ఆఫ్ చేయి కాక మూవ్ చేయకుండా ఆఫ్ చేయి ఎందుకైనా మంచిది ఇప్పుడు మీరు పెట్టి ఇప్పుడు మళ్ళీ ఆ మెయిల్ ఓపెన్ చేయి మెయిల్ సార్ మెయిల్ ఉండే జీమెయిల్ ఇక మెయిల్ ఇది క్లిక్ చేయండి అది ఎంత మినిమైజ్ చేసి సార్
We invite all participants to join for the tea outside of.
వచ్చి వస్తున్నాడు 5 మినిట్స్లో వస్తున్నాడు అలాంటి 10:20 చెప్పాను
Participate. Bit this main agenda of the all that centricity terminal understand I will in background. Present your crux of this classification. About me, I did my then I was aware that's a place where we have a lignite mine and a power plant. That's where I was born and raised. Just because we are doing it in Warangal, I want to highlight that way back in 2004, I have come here as a student to deliver my first technical paper presentation. So that's more than 20 years ago. So some of you might not have even been born by that time. So that's okay. And then my first trip abroad was in 2006 when I had an opportunity to go to Germany, Berlin, and work in a startup company. I didn't have any idea of what a startup actually means at that time, but I worked in a startup company without even realizing what it is. And then the intention of the company was to build an electric bicycle. It's a very interesting concept. The concept is electric bike which is not driven by human, but it is driven by a motor, in the sense that when you pedal, the pace at which you pedal, the rate at which you pedal, will be converted into a voltage signal, say using a DC generator, for example. So imagine the pedal is connected to the rotor of the DC generator. So the faster you pedal, more voltage will be produced. And that voltage will be the speed reference for the motor that is housed in wheel of the electric bike. Okay, so the faster you pedal, the motor will get a speed reference that will go higher and higher in magnitude, which means the motor which will be connected to the battery will be, the PWM will be applied wider and wider, and it will run faster, right? The reason why this is internship was quite interesting is because the bike, even if you pedal normally, could run at 45 kilometers per hour. So you can actually overtake a car going in the city quite easily without sweating, without breaking a sweat. And if you actually break your sweat, if you put in a lot of effort, you can go at 80 kilometers per hour or 90 kilometers per hour. So it's a quite powerful bike. So that was the concept that the company was working on. Of course, the company grew and then they sold and things changed a lot. It's quite some time now. Then I worked in 2007, after my master's, I worked for a company called as Osram. Osram is a combination of osmium and wolfram. So it's a lighting company, as you know, tungsten, and so that's the element used in lighting. So this is a Siemens umbrella company. This is based out of Gurgaon. Probably now it's Gurugram. Back then it's Gurgaon. So I worked only for a few months, but back then we did not have LED lamps. We had compact fluorescent lamps, and we had to design circuits for making the CFL work. And we basically removed the conventional inductive choke of the electric lamps, and we replaced it with electronic circuits or electronic choke, as we called it back then. I think again all these have now become kind of redundant, because we are now moving towards LED lighting mostly, and I think one of you mentioned about your research focused exclusively for DC-DC converters on LED lighting, right? Riddesh, right? Yeah, okay, good. So that's good. So LED lighting is the future, as I foresee, at least for the next 2 decades. Between 2013 and 2017, after my PhD, I worked for a Canadian company called Opal-RT Technologies. I did see this hardware-in-loop simulator at NIT Warangal. I know there is one at IIT Roorkee as well, and there is a hardware-in-loop simulator there. IIT Jodhpur also has these simulators. So these are very powerful machines. The idea of hardware-in-loop simulators is very simple. It came from aerospace industry. Imagine you being pilot and I being a designer. I come to you and tell you, hey, I designed a new controller. Would you want to go on a test flight? What would be your reaction? A little bit scary, right? You don't want to risk your life on a new control algorithm that somebody wrote. So the way we test out such control algorithms is we mathematically model complex electromechanical systems running in computers. It can be analog or digital computers. And we have to cheat the controller that the signal that the controller receives from this computer is as if a signal that's coming from a real plant. So we have to use appropriate wiring. Say if the controller needs a voltage signal, then we have to run a digital to analog converter from the computer, take the output from the voltage, feed it into the controller. And the controller will not know it's coming from an actual modeled plant. It will assume it's coming from an actual plant. And then it will react to it. Okay? So once we test it out, we are a bit more confident. Okay? So few more pilots are interested in testing a flight after we have done a hardware-in-loop test. HIL is not only used in aerospace industry, it started in aerospace. It's widely used in power sector, high power. For example, you want to build a high voltage DC converter station at a location, let's say at NIT Warangal. Like how would you test your controller? You cannot build a plant, a 3000 megawatt plant, just to test your controller, right? It's not practical. So you cannot build a high power plant to test your controller. So you need to have tools to model such systems and model accurately. And that's where HIL or rapid control prototyping environments like simulation boxes like this really come in handy. And Opal-RT Technologies, my primary job was to create models, test and validate for high power and electrical drive systems. Okay. So here the challenges are twofold. We have to build mathematical models to run in computer, which has to interact with controller in real time, and also we have to ensure that the hardware is not limited. Hello. Since 2017, I have been working at the University of Victoria. So this is my profile in a single slide. Okay. So if I take the world map, I was in Tamil Nadu, India since my birth until my engineering, and then I went to Delhi for my master's. Okay. And just my foreign trip was to Berlin. It's just a footnote. I don't know if it's important anymore, but and then right now I am on. Actually, I am on an island right now. Victoria is a town which is situated on an island, so you cannot actually drive or commute by road to my place. You have to either fly or take a boat or a ferry. You cannot swim, the water is too cold. And there are whales and sharks. No sharks, whales swimming around. So this, because it's a map, it's probably not visible, but basically this, if I fold it into a globe, if I make it into a cylinder, This point will be more or less behind the back of Delhi. What do I mean by that? We have a time difference of about 12 hours. So right now the time difference is 13 and a half hours. So my body clock is on Sunday night around 9 p.m. or 9:30 p.m., something like that. Okay? So in 2 hours I may feel sleepy. So it's your job to make me awake, right? Keep me awake. Anyways, so the place where I'm currently working, it's University of Victoria. It's one of the warmer places in Canada. Its temperature goes not below -5 anytime during the year. So the rest of the Canada can go as low as -25, -30 degrees centigrade. But Victoria is pretty warm, and in the summers it's very beautiful. So I have a picture of my university. So the building that you are seeing is the library building of the university, and this is the open space that we have. Compared to NIT Warangal, it might be much smaller or slightly smaller in size, campus-wide, but it's a nice university to be in. And universities in Canada are typically not restricted to technology only. So we have programs like engineering, sciences. So you can get a Bachelor of Science degree in physics or chemistry. You can also get a Bachelor of Arts degree in English or in history. So you can get a degree in psychology. You can do a law program, or you can do a business program. So university in that part of the world is slightly different. We have a school of music. The benefit of such programs offered within one campus is, I will highlight that when we have a school of music, when we have engineering faculty in the same campus, we have a course called computer music. So the course actually teaches you how to create music using digital technologies. So musicians come, engineers and technologists go into the course, they both work together and they produce. Okay? So there is a school of fine arts for theater or stage play, acting. Okay? So they use lots of technology, especially audio and visual technology, camera and microphone, right? So we work with them closely as electrical engineers to help them. So that's the benefit of a university of that nature. So this is the same university. So it's, as I said, it's on an island. The island is pretty big actually. It's not a small island, but the university is located quite close to waters. So you can actually walk to the ocean front. One of the major attractions is the State Legislative Assembly of the British Columbia. So Victoria is a capital city of the state, and this is where all the MLAs will meet and take decisions. Okay? So it's just to give you a perspective. Victoria, by the way, is one of the popular tourist destinations of the world, especially in the months of May, June. It's visited by tourists all around the globe. Okay? So you get lots of tourists. Anyway, so these introductions we have already done, so we are going to skip it. So I will get started with the lecture. So first, I want to give you all a perspective. So this is the data collected from Canadian government website based on 2021 year data. So this is the total energy or power mix of Canada. We have, if you really look carefully in this is a very it gives you a picture of what kind of energy mix is present in Canada compared to in India. 60% is hydro. Okay? Canada is water resources are aplenty. 14% is nuclear. Okay, so that's clean. One of the cleanest forms of energy production we can have is nuclear. And then coal, natural gas, which is orange and kind of grayish, constitutes about 17%. Wind is 6%. So if you see, more than 80% of total energy produced is already renewable or clean energy source. Right? So you need to put that in perspective. Maybe if you do a similar chart for India, you will get a different share of the pie chart. Right? You may not get 80% from renewable sector or clean energy sector. So this is for the whole of Canada. Solar is less than 1%. For variety of reasons. Number one, because of the weather conditions. It's not because of the cold nature, it's because of the precipitation. So if it is snowing a lot, cleaning solar panels becomes more energy consuming. That is the main reason. Temperature wise, it's not bad, but it is just the precipitation is the problem. So when it comes to the state where I live and work, it's called British Columbia. And in this state, the electricity production is pretty much all hydro. 89% is all hydro. So we are largely hydropower plant based electricity producers. We sell electricity to the US during daytime at a higher rate. We purchase back from the US at night at a lower rate and pump, in some places pump the water back, but not everywhere. But that's the idea. 6% is biomass, wind is 3%, and then very small percentage, less than 3% is natural gas and petroleum. So we don't have coal power plants at all in the state of British Columbia. Okay? So this is just to give you a perspective. Now, given the energy mix idea, I want you to be aware that Government of Canada has committed to sell only what is known as zero emission vehicles. That means vehicles that have a net emission of carbon dioxide which is zero. Okay? So it can be a hybrid car, it can be a purely electric car, okay? But net carbon dioxide emission must be zero. So zero emission vehicle. So all new vehicles will be only zero emission vehicles from the year 2035 onwards. That is the regulation that Government of Canada has is committed to, and they also have some phased targets. So by the year 2026, which is next year, at least 20% of new sales should be zero emission vehicles, and by 2030 it should be at least 60%. Only then we can meet the 100% sales by 2035. Okay, so this is from the state government, this is from Government of Canada perspective. The British Columbian government, the provincial or the state government, they were the first, in fact, before even Canada did commit, British Columbia introduced, because as you saw in the energy mix, British Columbia has an advantage that it's always clean energy, so they can go into electric vehicles and there is no dilemma. Okay, am I burning coal somewhere? No, nowhere, right? You are not burning coal anywhere. So BCE was the first government, in fact, around the world to legislate, make it a mandate that all new vehicles sold after a particular year will be only.
I believe that some of you may be working as a faculty and some of you may be doing your PhD. Means that are very mature participants, and considering your background into account, I will try to make the lectures more interactive and have more active participation from you also, so that I can also learn from you whatever background you have. It is a mutual process, and we know that teaching is a lifelong learning process. So this course is a 5-day course in which the main focus is on sustainable energy system. We know that In this course, the key focus has been, while developing the proposal, we thought that we have to utilize sustainable energy technology for the sustainable development of the society. Considering that high-level objective into account, Dr. Farooq approached me and he initiated the discussion that if we integrate AI, artificial intelligence or machine learning for achieving the objective of sustainable development, then it will be really a good proposal for getting it approved. So after having deep conversation and discussion with Farooq, we developed this proposal in which we are trying to learn that how the sustainable energy technologies implementation can be facilitated using artificial intelligence. All of us, we know that India has signed the agreement for being the part of United Nations Sustainable Development Goals. If we consider United Nations Sustainable Development Goals, there are 17 goals. In this course, we will try to focus on Sustainable Development Goal 7, which is clean energy access for all. Then it comes the sustainable technology. And then United Nations Sustainable Development Goal 11, in which the focus is on infrastructure. So for doing the infrastructure and getting it integrated with sustainable technologies, we have to use artificial intelligence. And then last goal, Sustainable Development Goal 17, which is correlated to co-creation of knowledge. It means that we have to work together in an effective manner. That's why we have this GIAN course using international expertise and taking into account the national expertise also. It means we are co-creating the knowledge together for Sustainable Development Goal 7. So overall, this planned GIAN course is going to contribute effectively on achieving United Nations Sustainable Development Goals. Now, our focus on my background. So let's come to my background. I am working on sustainable energy technologies from last 3 decades. Most of my focus has been how we have to develop sustainable energy technologies. For example, solar photovoltaic system, hydrogen energy technologies, electric vehicles, and energy storage. How we have to integrate them together, right? So that we can contribute towards the Sustainable Development Goal 7, where we have the goal of clean energy access for all. So I have given you a very high level overview of this course. And when we are talking about these sustainable energy technologies, we know that most of these technologies are nature dependent. Their output is going to be very intermittent in the nature. And then when we want to integrate them for reliable, sustainable energy supply, we need to have appropriate control system. And to have this appropriate control system, we need to use information communication technology for integration, and when we are using ICT technologies for integrating them, we are going to create huge number of data, and those data will be collected, and we have to process that data, and based on that we need to find out appropriate mechanism for managing and controlling the power output from this nature dependent sustainable energy technology, which is going to be possible by using artificial intelligence or machine learning. So that is the key point. So related to my academic background, Dr. Farooq has already shared with you about some of my academic background. In last 3 decades, I have worked in many countries, and overall the focus has been on sustainable electrical energy system engineering. During these 3 decades of experience, I have the opportunity for developing, creating new courses with focus on sustainable technologies for undergraduate and postgraduate programs at the world's leading universities. And all of us aware that when we want to do the teaching, at the same time we have to contribute in research also. It means that we have to teach the young researchers for doing their work related to the domain knowledge which I have, right? So that most of the focus of my research grants have been on sustainable energy system engineering. Okay, so that is a very high level background about me. Now, coming back to the focused background about me, because you should be aware that, and some of you are quite young, or most of you are quite young, right? So you need some encouragement also, and you should also learn like how the academic journey it works in the international context. So at this moment, I am working as full professor in smart grid and renewable energy at the University of Agder, Norway from last 12 years. That I have not listed here, but Farooq has shared some inputs about that. So before coming to University of Agder, Norway, I was working at University College London, and University College London is one of the world's premier institutions. And some of you may be aware that Mahatma Gandhi, Rabindranath Tagore, they were the alumnus of University College London. And University College London has more than 25 Nobel laureates in the credit. So the work which we do at UCL is always at very world class work. While working at the University College London, my responsibility was that to establish new school of energy and resources in which we need to develop new postgraduate programs for sustainable energy systems, especially for the industry professionals, and taking into account the multidisciplinary approach. So here, the word came now, the multidisciplinary approach. So here, with the help of this multidiscipline, I will explain that how the different knowledge domains, they can work together for sustainable energy system. So while working as director of program and senior lecturer, which is equivalent to full professor in many of the universities, the multidiscipline energy program which we developed, in which the students were not from engineering background, but some students They were from the background of economics, energy law, sustainability, environment, etc. Because we know that when we are developing the leaders for sustainable energy system, so the leaders should have the multidiscipline capabilities. They should be in a position to learn or to understand how this different domain knowledge they can work together in integrated manner for sustainable technologies implementation. Right. So here it is a really a big challenge for an engineer to teach to the students who are having the background of economics or the law, right? Because they don't have that engineering background. So it's really very challenging also, and also to engage them, like to understand how these different technologies work and how they can use their domain knowledge. So in this course, we are trying to use the some concept of energy technologies here and putting it with the help of machine learning. And so it is going to be a multidiscipline approach. So that was really a very good experience for me for developing this master's program in sustainable energy, in which the participants or the students were from different disciplines. And then at the same time, while working as a director of program University College London, I had the opportunity for being the board member of South Australia government's first renewable energy board also. So I have contributed heavily on developing renewable energy policies for South Australia, and in which we tried to integrate energy domain knowledge with energy economics, policies and planning. I feel very happy to contribute for that, because some of you may be aware that South Australia is running many times on 100% renewable energy. Right. So you see, I was there, the board member from 2009 to 2011, and now at this moment you can see that South Australia is running many times in a year on 100% renewable energy. So the policies which I have contributed at that time, now they are taking the shape for the implementation also. Okay. And now you may be aware that South Australia has demolished all coal-fired thermal power plants. Now it is running on the wind, solar, and for the peak load, gas-fired power plants also, and it has the integration or network integration with neighboring states also. So that was a wonderful experience for me also to learn that how the renewable energy policies should be developed, right? And how that learning can be implemented within the economy, for example, like our Indian system also. Right? We know that Indian government has agreed that by 2070, right, 2070, we will be achieving net zero. And many of the developed countries, they agreed to be net zero by 2050. It means that, what does it mean that? It means that we have to focus on getting more and more sustainable energy technologies integrated within our energy network, right? And to achieve that target, we will need some young generation and professionals to have not only the domain knowledge, but to integrate them within the energy system network. Sometimes we call it as a smart grid. And when we are talking about the smart grid system, so within the smart grid, we have to integrate information communication technologies, IoT systems, and many things together. Right? So then we will need different domain knowledge together also. And then when we are integrating all these technologies together, so of course they are going to impact the business models of the energy companies, or existing business models may not remain valid when we are moving towards the net zero. Means that we need to work on developing new business models also. Okay, so you see, then we will need to include the persons who are having the energy policy and the energy economics background also for developing the policy, appropriate policy, right, in which, right, the companies or the organization who are working on sustainable energy technologies, they can also get the profit also. So in many of my research projects and some of my PhD students also, they did their research work on this topic also, and slowly within this course we will discuss all of them so that you can also learn and I will also learn from your background also. So now, coming back to my academic journey, before coming to University College London and working as a board member of South Australia Government's Renewable Energy Board, I was lecturer at University of Dundee, Scotland. And while working at the University of Dundee, Scotland, my responsibility was that to develop new bachelor program in renewable energy and postgraduate program, especially for the industry professionals on renewable energy. So I did that work very successfully, in which the focus was that how we have to change the domain knowledge of electrical engineering to get it more focused on sustainable electrical energy technology. And when we are talking about sustainable electrical energy technologies, and within that context, how we have to include information communication technologies for integrating them, those courses were also integrated in that bachelor's and master's program while working at University of Dundee, Scotland, and I was responsible for that. And while working at University of Dundee, Scotland, I was lucky to get some externally competitively funded research project also. I will share them with you also. One of the project, it was funded by Engineering and Physical Sciences Research Council UK. That project, it was focused on the developing country and by taking into account the special case of our Indian condition, in which the idea was that if we are going to have renewable energy system within, let's say, off-grid area, then how we have to find out techno-economic optimum sizing of the renewable energy system for fulfilling the local demand of that system by taking into account the local availability of the resources, local availability of the energy pricing, and local availability of the infrastructure. So you see that project, it was in the year of 2007 or 8. So that work which I did long back, right? So based on that work, then recently I had 3 projects, and within that 3 projects, the focus was that how we have to integrate such type of distributed energy system within the main grid using information communication technologies and taking into account the centralized approach in which the decisions will be made by the virtual power plant centralized by using the continuous data collection from the users, and how we have to use that data within the, considering the security of the data as well as the privacy of the user, and based on that data, how we have to do the prediction analysis and developing the demand side management scenarios. So you see, So the domain knowledge which I got, let's say in early 2008 through a project that have been incorporated in the recent project which was funded by the European Union, in which we use machine learning for the prediction as well as the control system, security and privacy also, not only from the decentralized point but the centralized point also. So I will share with you, because we are here for 5 days, so giving a focused lecture on that project and how we have to use this machine learning techniques for such type of projects also. Okay. So that was a little bit background from the University of Dundee, Scotland, where I was working. And before coming to University of Dundee, Scotland, I was working at University of Jyväskylä, Finland as a research director. So that was a wonderful experience for me. And the learning from that experience will also help you and how the academic environment or the teaching environment, it works in the Nordic countries of Scandinavia. So when I was working as a research director at University of Jyväskylä, Finland, which was almost like a full professor position because I had that credential at that time, and research director position, it was on that level. So here, this education program for which I was responsible at the University of Jyväskylä, Finland, it was divided into the 3 parts. One part was the teaching, of course, we had to teach the young generation. Second part, it was related to the research also. And third part, it was more or less to engage the community. It means demonstration. Teaching, research, demonstration. And that demonstration to the society engagement. Okay. So in this, I worked there for 3.5 years. During 3.5 years, we developed the master's program in renewable energy. We developed the sustainable energy technologies demonstration for the community, and then of course the research. And this development or the implementation or demonstration activities were funded by European Union Regional Development Fund. And then that one was from the, let's say, demonstration point of view. Then I will come from the teaching, because most of us from the teaching are academic background. So in the teaching, right, this multidiscipline renewable energy program, it has a 3 domain. One was related to the technology, second was related to the environment, and third was related to the economics and the policies also. So you see how the students, they were integrated, right, in which they have more flexibility based on their academic background and interest to select the subject, whether, of course, from the technology, whether they want to learn from the environmental side or they want to learn from the economics and policy sides also. And here the professors have the complete academic freedom. I mean, complete academic freedom means you have full freedom to design your course, you have full freedom to design the timetable, you have full freedom to select which lecture room you want to have, and you have the full freedom to evaluate the students. There is not any type of bureaucratic regulations on academic knowledge and the dissemination from the professor. So that really I like, and I have not seen such type of academic freedom while working in many of the international schools. And the students, they were so honest and integrated. Always in every class you will find 100% attendance. Right? So that one was, let's say, from the teaching. Just I'm sharing some background. You should be aware that how the teaching, it works in some of the Nordic countries. Then at the same time, then I mentioned you about the research and demonstration. So having some domain knowledge in hydrogen energy technologies, right? And now we have seen that Indian government is also pushing towards the hydrogen economy, and it has a big target now, right, to use hydrogen as an energy carrier. So while working at University of Jyväskylä, Finland, I had the opportunity to develop. I will share that experience also in a very detailed manner, but just now, because it is an inaugural lecture also, just to create your interest and to have some background. So here, integrated renewable energy system in which the energy storage in the form of electrolytic hydrogen have been considered. So now here you can see how we are using the different domain knowledge. When we are talking about electrolytic hydrogen, so naturally it is a chemical engineering. When we are talking about the renewable energy, some mechanical, some electrical approach. But when we are integrating them using power conditioning devices, so we need to have the expertise from the electronics components also. And then when we are collecting the data, right, so of course we have to analyze that data, so we need the persons who are having the domain knowledge on statistics also, and of course then we may do that analysis or synthesis of the data which have been collected, maybe centrally or maybe in the somewhere on the server. So of course then we need to have some communication knowledge also, and then of course when we are doing some analysis of the collected data, we need to utilize some of the algorithms also, and then based on those defined algorithms and taking into account the different conditions into account, we need to make the decisions also. So some of the decision will be based on machine learning also. So while working at University of Jyväskylä, Finland, I was mentioning that to develop, I was responsible to develop a system in which we are integrating different renewable energy technology by developing different type of power conditioning devices, right, to store the energy in the form of electrolytic hydrogen, right. And then when we are storing the energy in the form of electrolytic hydrogen, right, then we need to utilize that also. So for that, in cooperation with local technical college, we developed a single passenger hydrogen fueled car also. So you can see that to develop a single passenger hydrogen fueled car at what time in early 2000, right? So it was a big challenge because at that time none of the leading automobile manufacturer were producing the hydrogen fueled car. But now we know that many of the leading car manufacturers, for example Toyota, Hyundai, they are marketing or demonstrating hydrogen fueled car also. So at that time the idea was that when we are talking about sustainable energy technologies, so when we are storing the energy in the form of electrolytic hydrogen, how we can utilize as a fuel in a single passenger car, right, especially in the Nordic climatic condition. So that work I did when I was working as a research director at University of Jyväskylä, Finland. And I will share detailed experience with project description, single line diagram with you also, so that you can also learn about sustainable technology development. Okay. And before coming to University of Jyväskylä, Finland, I was working at Hydrogen Research Institute, University de Quebec, Quebec, Canada, where I worked around 2.5 years. And during that 2.5 years time, I did a lot of research work on green hydrogen energy technology. So the work which I did at that time, let's say 25 years before, now that work is picking up, and in almost most of the all leading countries in the world, they are developing their energy policies, making towards hydrogen as an energy carrier, and then that hydrogen should come from renewable energy technology. So I will share with you my detailed working experience at Hydrogen Research Institute so that you can learn that, and you can see that by getting some learning from Farooq also, how you can use machine learning techniques for managing such type of energy systems also. And before moving to Canada, I was working at NIT Bhopal, and that experience was also very good. And at that time, my main focus was on electromechanical energy conversion, and I was teaching at that time generalized theory of electrical machines also, energy economics and planning also. And then before that, then I was at IIT Delhi, and sometime I worked with Government of India for a few months as a technical consultant on energy conservation and management. So that was my little bit academic picture. So I graduated long back in 1989. So I'm quite old man, and I moved out of India from early 2000, let's say, and from early 2000 then I'm just contributing heavily with international cooperation, collaborations on sustainable energy technologies, and how this sustainable energy technologies operation and the data can be integrated with artificial intelligence for energy efficiency and management also. Few years before, some of my PhD students, they used the machine learning applications for energy prediction, energy efficiency, and demand side management also. I will share that experience with you. Now, moving forward, when you are working in international university, so it is quite different to work or to have the work culture considering the Indian conditions. So whenever we want to do the research in any international universities, we have to find out the external funding. And to get the external funding, it is not very easy, it is very challenging, with tough competitive process, success rate always under 10%. So while working in all these international universities, most of my research work have been funded by these different research concepts. While working in UK, my research work, it was funded through competitive process through engineering and physical sciences research concept. Some of you may be aware that to get the competitive grant from the EPSRC is quite tough. Success rate under 5%. So let's focus on first EPSRC UK. What was that? So I will just give you a little bit idea. Okay. So when I was working at University of Dundee, Scotland, in cooperation with 2 UK universities plus 2 Indian organizations, we made a proposal how we have to develop off-grid energy system for developing countries, for example, like India. And not only that, but when we are going to have off-grid electrical energy system with more focus on sustainable energy technologies, then such type of system is going to need to have appropriate community engagement also. And of course, we need to take into account the available resources, available local energy consumption for making them more self-sustainable. In short, we can call it Urja Swaraj or energy independence, right? So for that, how we need to work on developing the architecture, right, in which we can have this off-grid electricity system integrated. So in this off-grid electricity system, what we consider here, I will explain you briefly here. So for a local condition, we want to develop the off-grid system here. I am going to share a detailed presentation about this also, but just now I am trying to give you a little bit high-level overview to create some interest in you. So when we are talking about the off-grid system, and within this off-grid system, we have to consider how the resources they are available at that particular location. Based on the available resources, and of course by taking into account the profile or the load profile of that local community into account, okay, and then at the same time with these local conditions, we have to consider the local economics also, because we want to make the sustainable development of this community. So the economics plays a very important role also, and considering the local load profile, economics and the resources, then we have to find out the optimum sizing of components which are required for this off-grid. Now, when we want to do this one, it is not that easy. It is not that. Now here I will try to explain you how we can use machine learning for this. Okay? And Farooq will teach you much more in depth about some of the techniques also. And as time permits, I will also teach you. Okay? So, but today we are at the starting. So when we are talking about the optimum sizing of the components which were going to be required for this off-grid system, taking into account the local resources, profiles, etc., that have been covered when I was working at University of Dundee, and then we got the funding for this project, right, through EPRC, and you can see that funding was around 2 million British pounds. So now here, when we are talking about this optimum sizing of the system components, right, so when we have to develop this project or decentralized or grid energy sustainable energy system projects, so naturally we have to take into account the technical or lifetime of this project. Let's say technical. So let's say if we take into account this type of off-grid project is going to remain, for example, let's say for the 25 years, for example. So within this 25 years, we have to make a plan that whether the system is going to remain the off-grid or going to be grid connected also. So naturally, economic conditions are improving, right? Technology is also improving. So there may be possibility that before the end of this technical lifetime of this project, this off-grid project may get grid connected also. Okay. So due to that, the economics is going to be changing also. Right. So now let's say when we want to design this off-grid system, taking into account the local available resources as well as the load profile also, how we are going to do that one and how we can utilize the knowledge of data, or let's say with the first objective of finding out the optimum sizing of the system components. How you are going to do that one. Now here it comes, you have to rely on the available data for that particular location. Some of the data may be available locally, but we know that in the world, many countries, they are not properly developed, developing, may not have the appropriate data available. So we may need to rely on the data available through the satellites, for example, from the NASA or so on. So when we are collecting the data for that particular location, right? So those data may be historically available. So for example, at this particular condition, if we are taking into account the hydropower potential, for example, so we may have some information, right, how the hydro resources are going to be available there. But we know that due to the change in the climatic conditions, the rainfall patterns are also changing. So now you see, we need to use the machine learning for predicting the available resources for that particular location, and those resources, when we are planning here this project for 25 years, so we can see that based on the historical data, how we can do the prediction of the resources, right? So I have given you one example of the hydropower or the rainfall patterns that is also changing with reference to the climate change patterns and many things also that is going to impact the operation of such type of off-grid system, if in which we are connecting the hydropower also, and then hydropower is going to be the sustainable energy technology. So you can see that how you can use your machine learning techniques for operation as well as designing of such type of. So here just I tried to give you a very high level example of off-grid. So it is not only from the solar rainfall patterns, but also depending on the location, we may consider the solar also, right? So here also with reference to the solar, we need to do the analysis based on the historical data and to get the prediction for the next couple of years also, how we are going to predict the solar radiations. In the solar radiation also, of course the solar geometry is going to play the major role, but in addition to that, here I am trying to explain you that how we can use the machine learning techniques or AI techniques. So if we are considering the solar here, right? So because all these factors have been considered in this project, that's why I'm explaining you here. So in the solar, let's say, because we need to know the local resources available. So for that local resources, let's say if you take one condition of the solar, so here we may have three components into account. One, direct component, diffuse component, and ground reflected component also. So here, direct radiation that can be estimated, but that direct radiation, incident direct radiation at that particular location going to depend on many other parameters. For example, climatic conditions, if we are going to have a lot of clouds, right? So during rainy season or during non-sunny days, we may not get the direct radiation. So to get that understanding, then we are going to have those weather conditions. So those weather conditions need to be predicted by using AI techniques also. Okay, so to predict that direct radiation, how we can use the AI techniques? There are many prediction models are available. And these prediction models need to take into account the impact of external parameters. I will explain that. And I will share some of the articles or peer-reviewed articles which have been published by some of my students, you also, and through that, then you can have more deeper understanding that how we have to take into account the impact of external parameters for doing this prediction. And for just here I am taking one simple case. We want to do the prediction of direct solar radiation. That direct solar radiation patterns throughout the year, and then when we are talking about the system for next 25 years, right? So we should have the understanding how the energy output is going to be there. So that is also. So here you can see that how we are going to utilize domain knowledge together with machine learning also. Similarly, if we go with the diffuse radiation is very important when we don't have the clear sunny day. Then diffuse radiation is going to play the major role, and this diffuse radiation again it is going to depend on weather patterns. So here you can see that weather patterns are very unpredictable. So to predict that weather patterns for calculating the diffuse radiation, we have to use some techniques. So we will use some machine learning tools for predicting these weather patterns and calculating the component of the solar radiation, that is the diffuse radiation. So then third component which I mentioned here, it is a ground reflected component. So this is also a very important because this will depend on the ground reflection coefficient. So ground reflection coefficient is also going to change with reference to the time, right? Maybe when we are planning such type of system here, right, at that time the ground conditions may be different, but in future the ground condition may get changed. So this ground condition is going to depend, right, whether we are going to have a lot of plantation in that area or which type of ground conditions are there. So for that also we need some prediction analysis. And then with the help of this prediction analysis, when we calculated the solar radiation, which is a combine of direct diffuse and ground reflected component, and then we have to see that when solar radiations are coming here, what should be the optimum tilt angle here also. Because that optimum tilt angle is going to be very useful for getting the maximum resources at that local condition. So now here you see, with reference to the time, with reference to the change in the climatic conditions, these things are going to be changed, right? So with reference to that, we have to focus or we have to do proper technical analysis for finding out the optimum tilt angle. So then, when we are getting the proper understanding, right, here how much input is going to be there, right, so then of course then we have to take into account here what type of photovoltaic technology or solar technology which we are going to utilize, right. So we know that with reference to the time, the technology is also changing, right. So we have to see, let's say, what technology is available, or maybe in next few years what type of technology will be available, and whether that technology, right, based on this input what we are going to get here, how it is going to behave, right. So whether we are going for the single crystalline, multi-crystalline, amorphous type, or this now a new solar cell perovskite is also coming into picture, right. So now here from the engineering point of view and from the domain knowledge point of view, you have to see that this available different type of technologies, how they can interact with the resources which is calculated, and how their energy production is going to be there, and how we can predict that energy prediction also. So I will share with you at some point published research papers also, in which you will be in a position to understand that how the prediction of the energy from a particular specific case, right, can be done, and because that will be required when we are talking about designing of this off-grid energy system, in which the focus is on optimum sizing of the system, right. So you see how we can use this different domain knowledge together on developing sustainable energy system, and this sustainable energy system is going to last, let's say, maybe for 25 years. Within that 25 years of time, right, we have to take into account the economics also, and all many factors which we can discuss days and days also, right. So here you can see that how is the AI or the machine learning is used here for calculating direct diffuse and ground affected solar radiation, for calculating the solar radiation at that particular place. Then of course then we have to use some algorithms, some physics based machine learning for calculating appropriate tilt angle of that one also, and then our next of our objective is to get the energy output from here, right. So to get this energy output from here over the time, of course we need this incident, but at the same time we will need the technical characteristics of the photovoltaic system components also, which are going to which we are going to use, and this technical characteristics, for example, here in the solar photovoltaic system is going to depend on some factors, let's say operating temperature, environmental condition, degradation factor, wind speed, and right, and with reference to time it may have some degradation also. So those factors also we need to take into account, right. So it's quite interesting to see, okay. And then when we got this output, energy output from this system, and of course it is going to depend on the nature, okay. So this is a nature dependent output, and of course we want to have in this off-grid system reliable and sustainable power supply. So we have to see that how we can find out the other system component sizing, for example energy storage or distributed generators also, okay. So then that also we need to integrate it together in finding out optimum sizing of the system components for what condition, to have self-sustainable reliable power supply by defining the appropriate reliability conditions of that particular location or of that particular off-grid load demand. Then another point which might have come in your mind, that let's say when we are talking about this system component sizing, then this system component sizing Okay, that is going to be our base. But when we are talking about technical lifetime of 25 years, so during this technical lifetime of the system, there may be replacement of the system components. None of the system is going to remain for the 25 years, right? So it will be aging, some of it will come out of technical lifetime also. So how you are going to predict the system component replacement, right, for this particular off-grid system? So that will depend on operational parameters, how we are operating them. And to get that operational parameters, now we are still at the point of the system sizing. Okay, so when we are talking here about the system sizing, you can see that how we need to predict the operational conditions of next 25 years. For what purpose? For finding the system component replacement over the lifetime of the project. And then that will be required for us doing the planning or developing the policies for operational of such type. So you see, we are trying to integrate domain knowledge, operational knowledge, data science, economics, many things together for this sustainable technology development. So all these factors were covered in this project, which was funded by EPSRC UK long back, and successfully we completed this project. So all the components, we were not in a position to do that one, but some of the components which we studied in this. So I believe that you might have got some high level understanding that when we are talking about sustainable energy technologies or the system, how we have to integrate different domain knowledge. Without that, we cannot move forward. That's why we tried in this course, right, how we can use sustainable AI or maybe machine learning. And when machine learning comes, when we have the available data, right, when we want to do the prediction. And when we want to do the prediction, so of course Farooq and his team will share with you some prediction models also. But for the prediction models, right, what inputs we are going to give, and to get those inputs, right. So let's say here, if you take that condition into account, then we need to have some understanding of this also, how the direct radiation has been calculated, how the diffuse radiation has been calculated. Means basically physics-based machine learning will be, right. We have to utilize the solar geometry also. And not only that, we don't want to have the only resources available here, but we want to have the output here, because that is what we are going to use. So here then again we will need the technical information. In some of the courses we will study, or in some of the exercises we will study about all these points, and also I will share some of the published by my research students with you. I will provide it to the Farooq and he will share it. Is it okay? So shall we have some break now, or what time lunch break is there, Farooq? We can have lunch break now, or at 1 o'clock. So we can have, let's say, 5-10 minutes break and then we can start. Okay. Let's have a water break. Okay, and then we can start. Talking about this project, right, which was funded by EPSRC, and I tried to explain you in a very brief manner what was the objective of this project. And to get these objectives, then of course we need to define some work packages, objectives, deliverables also, and accordingly we need to make the planning of the budget also, right? So that has also been considered here. So let's say that goes under the category of project management and planning. So we will not focus on that one, but more we will focus here, let's say after the break, on getting information about how we have to develop the key task related to this project in which we can utilize the knowledge of data science. Now, based on available resources at that local conditions, which we need to calculate by using physics-based machine learning approach, and then taking into account the selection of the sustainable energy technologies which we can fit here, for example hydropower, for example solar photovoltaic, for example then the wind also, because at that particular location wind may be there. Okay, so all these things we need as the input. Then at the same time, not only the technical parameters we need as an input, but we need to make this system profitable also, economically viable also, and all these different technologies, they may have different cost functions also. Because every technology is not going to have the same cost function. So those cost functions of these different sustainable technologies which we are going to consider here. That we need here. Otherwise, we will not be in a position to give the optimum sizing. When we are talking about the cost function of different system components, correct? We need to predict how the cost is also changing. When I did my PhD long back, in let's say early 90s or mid 90s, that time cost of the solar photovoltaic was free. I think if I remember correctly, it was around $5 per watt peak. Now it is maybe a few cents per watt peak. So you see, if at that time, based on that calculation, if I might have did the analysis for getting the optimum sizing of the system component, so that might have been failed enough. Because the article is very high cost function, but now the cost function is very. So that cost function prediction is of course very important. I'm not sure that are you in a position to read this one or not, because it's small handwriting. So don't worry. So in the next lecture, I will try to bring the document camera and do it projecting. Okay? Then it will be more visible. Okay? So to because today we have the inaugural session also, and then first inaugural lecture also. So I was not able to bring all these things, right? But I will bring so then it will be more visible for you. Okay? So my apologies for that. So now, considering here for doing this optimum sizing of the system components, whether it is a solar or wind, right, or any or hydropower, also many things are there. We need to have appropriate cost functions. Now, based based on historical data and based on the technology development, someone can predict that how the cost of that particular technology, for example, solar photovoltaic, is going to be declining, okay, right? And when we are planning to install such type of system, right? At that time, that cost, how much it will be there. Okay? So you see how the persons who are working in, let's say, machine learning, data science, can utilize their knowledge using the domain knowledge of sustainable energy technologies for this particular condition. Now, focus is here on getting the optimum sizing of the system component. For getting this optimum sizing of the system components, technical parameters, economical parameters, operational parameters are going to be required for doing the engineering economic calculation for 25 years. For that, some of you may be aware that we have to calculate net present value of the system. So to calculate the net present value of the system, we need to consider capital recovery factor also, CRF also. We need to consider over the system lifetime how these system components are going to be replaced over the lifetime of the system. Because let's say if we consider the solar cells or solar photovoltaic array, right? So they are having the lifetime of 25 years, right, technically. But their lifetime, again, it is going to depend on the operational conditions. I will share you another example because that we covered in another project. So, but only the solar photovoltaic arrays are not there. But to connect the solar photovoltaic arrays, we are using electronic components or power conditioning devices. So we know that our power conditioning devices may last maybe 5 years, not more than that, right? And sometime we get the technology improvement also. So we may need to replace them also. But here we are talking about the 25 years time, for example. So within that 25 years time, the power conditioning components which we are selecting for connecting the solar photovoltaic system to the, let's say, grid or integrating, we have to see within that 25 years time how many number of replacements will be there and at what time, right? So that number of replacement or replacement time is going to depend, of course, technical lifetime of that component, but at the same time operational conditions. So that operational conditions now here we are at the planning stage. So we have to predict that one. So the prediction of the operational conditions, how it will depend. It will not be just simple calculations. No? It will depend how the solar resources have been predicted for the next 25 years, let's say, or next, and then how that system is interacting, right? And that prediction is not only like only one value, it will be with reference to the time. With reference to the time. And when with reference to the time, during night time we don't have, during daytime we have. So all these parameters, continuous operation and intermittent operation, all of us we know that it is going to impact the operation of any system, right? For example, if you are driving the car continuously, its lifetime will be reduced. If you are driving the car daily 1 hour, 2 hours, its lifetime will be longer. Like so, those parameters now you see that. So it comes to the prediction or some models we will need to require, and that prediction should be with reference to the time. And that system component replacements we need to take into account, right? So that replacement of the components here are finding out the optimum. And let's say for a particular component, for example, if we predicted the lifetime, for example, 5 years, so it means that after 5 years, we have to replace it. So after 5 years, the cost of that system component is not going to be the same what is today. We have to predict that one also. How we are going to predict that? Right? So we have to use some historical data, development of technologies. Maybe by the time what the system component was there, it may be with reference to some present condition, but after 5 years, with reference to the improvement in technology, right? It may come with different configuration also. So that also factors we need to take into account. And for that, of course, we need some physics-based machine learning tools. So then, this after 5 years, then let's say 10 years, of, for example, 15 years and something like that, 20 years. So all this cost is going to be occurring after some time. But we are doing the calculations, or we're doing the analysis at this moment with the present condition. So how we are going to calculate the cost of the replacement components over the lifetime of the project to the present condition, it comes under the net present value. Okay. Then, because in this project it says that the word is off grid. It means that it is not going to get any power supply from the main grid, and we will need sustainable energy supply. And of course, when we are talking about sustainable technologies, they are nature dependent. So then we need to have appropriate energy storage also. So when we select the appropriate energy storage, whether it may be the battery bank or maybe some other. So battery bank or energy storage under this condition is going to be a key component. I will share one very good example with you with a detailed explanation with mathematical calculations and the results with you because we are here for 5 days, okay? So don't worry. So when this energy storage component is going to be there, now all of us are engineers. We know that this energy storage operation depends on charging and discharging cycles. Based on charging and discharging cycles, then only we can predict the lifetime of the energy. Okay? So it is not that easy because even we have the batteries in our mobile or in your laptop or anything. So all its lifetime we know that it depends on how we are charging and how we are discharging or how we are using. So that charging and discharging patterns of this energy storage system, it is going to be the key component here. How we will calculate? We will calculate based on the available energy from the resources, based on the consumption of the load profile with reference to the time. Then only we will be in a position to calculate charging discharging cycles also. And then not only that, after getting this charging and discharging cycles, that will be used in calculating the technical lifetime of that particular energy storage. Because every component has different electrochemical reaction, electrochemical equations, and based on that we can predict, right, by using, there are many techniques now, how much lifetime. Okay. So now here you see, I'm just trying to give you the high level understanding of this project which we are discussing right here, how the different techniques can be used. Okay. So now, with reference to this charging discharging cycles, which we need to predict based on the changing resources condition, input resources condition, based on the changing output conditions of that one, right? And then why we need that? Because we need that to find out during the lifetime how many number of times these replacements will be. Otherwise, we will not be in a great position to get the appropriate optimums. So this work, like what we are discussing, it is equivalent maybe like a more than a PhD work. Because it needs a lot of efforts, a lot of inputs, a lot of full concentration. Okay? So maybe some of you who might have not did the PhD and interested in doing the PhD also can consider this topic and can make a proper work plan for getting the appropriate funding for your PhD work. So, coming back to this point here, they, after getting the cost of the system replacement components, including the energy storage, we need to calculate net present value, in which we will use capital recovery factor and many other factors. When we calculate net present value of the system, we need to take into account depreciation rate, market interest rate, okay, capital investment, and capital investment for that particular technology also. And of course, the system will be built maybe by some government agency or maybe some enterprise or maybe by some organization, let's say. So everyone wants to make the profit, nobody wants to lose the money, right? So they have to see that how the investment is going to be there, and of course on that investment when it is related to the sustainable technology. So there may be some policies from the government on some discounts also or some financial incentives also. So those factors also we need to take into account for calculating the net present. And then of course from such type of system, the output is the energy. And that is also time domain and going to change with reference to the time or the lifetime of the system. So based on that, we need to calculate levelized energy cost of this, that is LC. So that levelized energy cost of the system is going to be a very dynamic function. So that dynamic function is going to depend on what sizing of the solar, wind, hydro, energy storage we have selected or we have put as an input. So then we have to do some calculation, right? And by varying the sizing of these different components within a particular maximum and minimum limit, and then we can calculate the levelized energy cost, right, from this off-grid energy. So here you can see that to calculate levelized energy cost using the net present value by taking into account all this prediction, right, then we are going to get the levelized energy cost lower, right, by varying all these parameters. And then at that lower cost, we will get the optimum sizing of the system. Okay, so here some of this, not all, some of these factors have been considered in this project. It was funded by EPSRC. So now, here you can get the idea. If we want to make some proposal for getting the funding, how we have to make a plan, how we have to define the research objective, and based on this research objectives, how we have to define the work packages, tasks, and deliverables, and how we have to do the final outcome. Right? If suppose we are not in a position to do the work plan properly with reference to the research objectives, So the funding which have been granted, they may not release the complete funding because everything is not coming immediately. They will see your progress. After your progress, after reviewing the progress, then they will release the additional. So being the end researcher here, right, you can see, right, how we have to utilize this upcoming machine learning techniques for doing such type of works, right, in which we may need, right, or we may get more appropriate results and we may not need to do all the calculations. Is it okay? So are you in a position to understand this project? It was a quite long project, but I thought I will present this project high level overview to you so that you can utilize your background, for example, of the electronics or engineering background or economics background, machine learning background on such type of project. So do you have any questions? Or do you like to have any feedback from your side on this topic? Yes, please.
The current scenario of
This project is over. Okay. So we prepared the reports, we delivered it, and it was approved. So this I think I have missed, and I will go on the business model. So the learning what we did in this, right, it was very useful. And based on this background, or based on this track record, that is much more appropriate. I had another project with Sri Lanka. That one was also funded, and we developed, or we extended the work of this project for Sri Lankan context. And in that work what we did, it was because after considering all this work, we developed the system of grid. Okay, that's okay, very good. But we know that economy is improving. So in future, this system of grid is not going to remain off grid. It will be grid connected. At some point, maybe after 5 years or 6 years, like so everywhere the transmission lines are. So we considered that also. If suppose this system is going to be connected to the grid, but we did the economic analysis at this point only. It is going to be connected to the grid after 5 years or 6. So then this system is going to be operating with interaction to the main grid. Here we designed the system from the energy independence point of view or energy storage point of view. But now, after a few years, when it will be again connected to the grid, so its operation is going to be changed. Operation is going to be changed. So how we are going to do that, we considered in the project, which was in cooperation with the Sri Lanka government, and some funding were from the Norwegian government also. So one of my students, she did very wonderful work on that one, and her work has been published in peer-reviewed conference and journal articles also. If you are interested, I will share with you also. And this topic is very interesting because after finishing this course, when I will be back in Norway on 26th or 27th of February, I am PhD examiner for one of the PhD candidate from NTNU and Norway, for them. So that candidate is also pending her PhD. She is a German girl, right? Related to this topic, and then in Norway, like our PhD examination is quite different compared to here. So we have to give one trial lecture topic. So that is also a good point to share with you, especially with the research scholars and academics also. Like in Norway, the PhD examination is quite different. So when candidates submit the PhD thesis, it goes to international or national examiners. They evaluate, they prepare the report if any feedback comments. So if suppose the examiners thinks that thesis is worthy to defend, okay, so then they ask the candidate to not only to present the work, but they give the candidate another topic that we call it trial lecture. That trial lecture topic is different, and that topic is given to the candidate before 10 working days. And then that candidate has to prepare on that trial lecture within 10 working days and to present that topic. Okay? And then if a candidate, 45 minutes only, if within that 45 minutes, examiners and jury basically, they check whether the candidate has the knowledge to use that PhD experience, right, for a topic which have been given as a trial. If the candidate passed the trial lecture, then the candidate is allowed to defend the PhD. Yes. Within the same day. Then maybe after 1 hour or 2 hour break, then candidate comes and then defends. So here I want to say that, because why it came to my mind, I'm explaining you this topic and the PhD examination, which I am main examiner there on 27th of February. I have given the topic as a trial lecture to the candidate. If suppose we have the off-grid system and going to be grid connected in future, how its operation and economics are going to impact. Right? That is the trial lecture topic I have given. And if you are really interested in this topic, I can share that link with you and you can watch remotely from here also through Microsoft. Okay? Both trial lecture as well as the main lecture also. But generally, the online participant or the remote participant, they are not allowed to ask the question to the candidate. If you have some questions, for example, you can write that question to the jury or moderator of the jury, and then moderator of jury, if he or she thinks that question is appropriate, not inappropriate, so then only he can ask. Right? Sometimes it happens like people you ask some inappropriate questions to the candidate. It is not good enough for the candidate also, and for everyone is not good if suppose someone asks an appropriate question. So that topic I will share that link with Farooq, and Farooq can circulate among all of you. And if you are interested and if you have the time, then you can follow that, and maybe then you can enhance your learning, like how the international researchers, they are thinking or about such type of. So here you see off-grid to grid connected. And then this off-grid to grid connected, when it is happening, right? So this system is going to work as, please tell me how it will operate. It will operate as microgrid. It will operate as microgrid. And then I will share with you a very detailed work of one of my PhD students, how this grid connected system should be operated as microgrid, and how we have to develop the strategies for operation of such type of system. And in that PhD, we have considered a typical case of India, because it was funded by Royal Norwegian Embassy in New Delhi in cooperation with TERI, the Energy Resources Delhi, in which we tried to do the analysis of institutional energy system by taking into account our typical Indian grid outage condition using distributed generator, battery banks, and then finding out how we have to have such type of microgrid architecture by classifying two types of load, critical load and non. Okay? Then, because I think maybe I will we will complete this before the break, then after the break, then we can have another break. So then another very interesting point which I was trying to mention you, when we have the resources available, when we have the resources available, when we have the solar photovoltaic panels here, and we know that technically, like in good idle condition, these PV panels may operate 25 years. But if we don't have the good operating conditions, then the lifetime of the photovoltaic panels reduces. That we considered in another project also. So here, this technical lifetime of the PV panels is going to depend on the operational conditions. As all of us, we know that cell operating temperature is the key factor here. If we are having higher cell operating temperature, right? So lifetime or the degradation of the photovoltaic panel is going to be there. Oh. So to find out that one also, we need to do some prediction analysis, or maybe we need to find out the way in which the operating cell temperature should not high. It means proper ventilation of the photovoltaic panel. Is there. So to have this proper ventilation of the photovoltaic panels at a particular condition or the location, we have to see, of course, the wind conditions also and tilted angle also, how much space we have given for extracting the heat which have been generated by the solar photovoltaic system, so that solar cell operating temperature is going to be low. Right? So here you see, of course, we need to use the physics of the solar cell operational conditions and all these things. But then predicting the solar cell temperature, operating solar cell temperature under these different climatological conditions or the weather patterns is going to be a challenge also. So then for that we have to use some machine learning techniques also. So we will study in this 5-day course that also. So then you will be in a position, right? So taking a typical case, right, in which we can use data science also and use that data science for getting out the optimum sizing components and replacement of the system component also. Is it okay? Now I was briefly I will explain because now you may be hungry including me, so we have to go for the lunch also. So here, this one it came to business models. So success of any project, it depends on the business, how we are making the money. Otherwise, same it is happening with the education system also. If you are not making any profit, right, there is no meaning to run any program or anything. Right? We are not getting this. So same here. Let's say we have this system here is going to be grid connected. When it is going to be grid connected, right? So grid is going to have different energy prices. This system is going to have a different prices. Okay? And here we are taking only the levelized energy cost, but now we have to take the system component cost also. So that is another point which we will not discuss here. But when this system is going to be connected to the grid, this is having different energy pricing. This has a different energy pricing models. Okay? And then of course we have to consider the energy price, power price, many things are there. Right? So due to that, the existing business models of energy systems are not going to work. Because due to the commitment from the government towards the net zero in achieving the sustainable development goals, and also India agreed that by 2030 they want to increase the renewable capacity by 3 times also. Right? So it is going to impact the businesses of the existing business models of the energy system. With reference to that, how we have to create new business models? Because everyone wants to make the profit. Given the existing system, they may say that we make it in the loss, or we may have to operate at the lower we may have to operate at the higher cost with lower return, right, due to this. So for that also, then we can use some machine learning techniques or physics. Okay. In some of our projects, we did that also. So we will cover slowly everything. Okay. But today, now I will stop here, and we can have good lunch on the first day. Okay. So thank you.
And his PhD from VNIT Nagpur with specialization in image and computer vision and digital image processing. His groundbreaking research is image detection has been international recognition and publication across various journals and conferences. His profile research, it covers about 150 publications which include SCI, Scopus Index Journal and top-tier international conferences. His research spans multi-domains such as artificial intelligence, embedded system, VLSI design, biomedical image processing. Sir is presently guiding 2 full-time PhD scholars, 6 part-time PhD scholars, and Sir has guided 3 students which are awarded with their PhD. His scholar work contribution towards his real-time world challenges like automated driving, healthcare monitoring, and image processing. Sir has been funded with many projects. In that, one of this 6G technology, where it was funded with 35 lakhs, which is sponsored by TIDF. The title is Empowering Health AI Enhanced Remote Monitoring for Elderly Care Patients with Variable Biosensor. So, and Sir has contribution in towards like many. He was organizing many FDPs and he was organizing many workshops. This program has covered the topics like AI, machine learning, computer vision, image processing, and FPGA designs. So, which will be very benefited for the students, faculty members across the nations. So, Sir had contributions with the industry leaders like international researchers across. He is associated with different foreign professors with South Korea, Norway, and many other countries. The main his deep learning research areas could be deep learning, AI, sustainable technology. And Sir is a senior member of IEEE and fellow of IETE. Sir, his leadership extends beyond the teaching experience and inspiring further for research learning. So we are very glad that Sir is joining us, and Sir will be speaking today's topic, Introduction to Machine Learning and Artificial Intelligence. Welcome you, Sir.
Thank you. So thank you, dear participants. We are going to start our next session. So as per the title of our program, that means in this course, and we have designed the course related to sustainable AI, how we can utilize the soft computing in terms of artificial intelligence, and especially in artificial intelligence, we are under the umbrella of AI. In that, machine learning and as well as deep learning we are going to utilize. So machine learning and deep learning basically will discuss how we can utilize, especially for sustainable development in terms of energy, in terms of healthcare, or in terms of different fields where we are going to apply the machine learning or AI to predict the particular that various data will be available. So in particular data science, our concern is related to data science, how we can solve the problem, especially for sustainable development. So in the current trends, we have observed various applications like autonomous driving applications. If you have seen the example of autonomous driving applications, or particularly driverless car, or telemedicine, that is means we should not require to go to the doctor directly with respect to various variable sensors. The data will continuously monitor with respect to our smart devices which are available, and we can transfer the data with the help of various communication module, and then the data will be transferred to the particular medical hospitals or medical practitioners, how they can interact with the patient and how we can rescue, and we can provide the directly without contact to help to the patients with respect to various disease, and sudden impact will be there. Okay, so ultimately in this case, how sustainable development will come. Okay, so related to cyber security is one of the part, related to power optimizations, because power consumption is one of the requirement. If you are using mobile phone, you are working mobile phone, so how much time you are able to utilize the mobile phone. That is the main, that means limitation for us. So any devices which we are using, like example of smart grid. In smart grid, the complete energy, how energy management, power management is going on. So power transmission, then power delivery, and then utilization by various appliances. So after 10 years, if you will observe, complete internet system will be developed, like complete computer system has been developed so far. When we started our research in AI from 2000 to 2010, we were under only development phase. But 2010 to 2020, we have completely done the implementation of computation resources. Now we are not worrying about computation resources. We have high computation resources. We have cloud, like you can utilize Google Colab. That means you should not worry about computer, you should not worry about memory inside the computer or whatever the resources required for computer, does not matter. You can write your program at anywhere, at any platform, because Google has provided server. So you can directly just write a program, run the program with the support of GPU, TPU which is available with the cloud server only. So that changes we have seen last 10 years. When I have done my research, I was using that computer that was around 256 GB MB, like that only, or till 1 GB, 2 GB RAM was there. Now we are not just going that direction. We have workstations that having the 128 GB almost memory will be there, and i7, i9 processors are there, multi-core processors are there. That means we have almost done the computational implementation. We are not worrying about computational resources. Likewise, after 10 years, you will observe every system will be deployed communication. Like a car will be deployed communication. So just assume you have a car. Inside the car, you are connecting your mobile phone and you are providing internet. You are listening songs like that. But complete IC will be inserted to the system, like a chip, whatever the like SIM you are using. So it will be equipped SIM, and complete car will become one mobile phone. It will communicate each other. So when it will be possible, you are able to drive the car with respect to without any driver, because driver does not require. Driver just only sitting beside, but car will automatically drive with the support of all automation system. How automation system will work? So various sensors will deploy. We have RGB sensors, like a LiDAR sensor. LiDAR sensor, that means depth or distance detection will take place. So we have to observe the entire scenario on the road, how we can grab the data which is available on the road. We have to identify which is that object will be there, and all cars we can sense each other. That means we are unable to sense now the car because we are driving, we are observing by eye. So our eye is sensing the distance, how much distance is far from that, how much you are able to manage to drive the car, what speed can we manage. Same thing will be deployed to the car. So at that time, that means entire computer system will involve in the device. So all devices are able to communicate each other. That is the agenda will be there. So after 10 years, we will enrich in the technology in terms of communication. That means now we are working in 3G or 4G, but we are not able to receive the bandwidth at that much level. We want bandwidth to run the like a autonomous driving car or driverless car. At least should require minimum 5 Gbps per second data. 5 Gbps per second. If suppose network will fail, so car will collide to anyone. That is another problem. So these are the situation, these are the hurdle will be there. In that all aspects, main thing is power. Main thing is power, because your all entire towers are working with power only. Either your mobile phone is giving power, either tower itself power system is there. So ultimately we want to enrich into energy system only. For energy means we are looking on renewable energy system, because after 10 years what will the situation will be there about energy system. Okay, we cannot rely on non-renewable energy resources for long time. That's the reason we are looking sustainable development. So if you are an electronics engineer, if you are electrical engineer, if you are a computer science engineer, that is I am an electronics engineer, I am working related to computer vision, image processing, machine vision, but ultimately our concern is sustainable. Sustainable in terms of healthcare, sustainable in terms of energy system, sustainable in terms of electronics engineering, sustainable in terms of electrical engineering, like smart grid, I give you an example. Smart grid completely system will be smart, or all power transmission, power just like a generation, and power delivery. That means the example of Internet of Things. So all devices will be having internet. So we are having mobile phone still, we are having watch still, but we want some other devices. Like you have many sensors which are required to measure your body parameters. Some sensor which is required how much distance you have traveled today, how much distance you want to go, some alert, many things. That means your device features will improve. Okay, so all these kind of things we are going to employ the AI. That means our concern is how machine learning and AI that will be involved. Okay, so we'll see in the talk how machine learning and AI, what is the understanding of that, and related to that you have to observe. So as we have seen here, AI is what? That means AI is the simulation of human intelligence. As of now we know what is AI, that means we want to know this is the complete AI, artificial intelligence. So under the AI there is a subset will be there, machine learning, inside that deep learning will be. But AI will support to what? Different disciplines are available. That means you can see cognitive science, you can see like a language translations, or various smart other different disciplines are there like robotics or different disciplines. So that AI is the big umbrella, will support to everywhere like energy systems, like electrical engineering or computer science or medicine. So various area we want to cover. But basically what is AI? We are human and we work as based on the knowledge of HVS, human visual system. How human visual system will work? We are observing through our eye, and this is connected to our brain. So brain is that is our intelligence, human intelligence. So completely we are going to mimic the same behavior inside the machine. So machine will be able to take the decision with the respect of various data. Data will be collected either in terms of various sensors or either in terms of vision. Vision means camera. So various other cameras are there, or depth camera, RGB cameras, LiDAR cameras. So many sensors are going to equip and collect the data and provide the various algorithms. That algorithms are responsible to predict the outcome. So basically how human brains are trained, just like we are going to learn with respect to our childhood to now, various studies we have taken care, various subjects we have studied. Then our brain has become completely trained and we are able to take the decision based on that training only. So same way we are going to design a artificial intelligence system. That system will be able to take the decision with data. Now data will be also categorized. Sometimes data is going to train with label or without label. What is the meaning of label? That means data is having the particular label and their ground truth or their exact output. So we are going to predict and we are going to match with that output. Then we can say, okay, that algorithm has learned. Like example, how we have learned about apple versus any example ball. So we have two objects with us. One is apple of red color. One is ball of red color. And you have to differentiate. So initially how you have learned about that object with respect to various features. So you have to go for feature extraction. After the feature extraction, we are going to forecast, we are going to predict based on the various classifier. So various features, various stages of the features also will be there. Does not mean directly you are able to extract the exact features. You are looking various features started from low level, then medium level, then high level. Then these features, earlier days we were extracting because we were not having computational resources very strong. It was taking too much time to train the 2000 data in terms of images. It was taking 10 days, 20 days when we were having 2 GB memory. Okay, CPU also not that much strong. i3, before i3 dual core or core to dual processors were there. Now we are in terms of multi-core processor technology. So we are not worrying about the data. Now we are able to get the minimum data 50,000, 60,000, like MNIST data set is there, 60,000 images are there. CIFAR data set is there, around 50,000 images. So various category, various applications, huge amount of data will be there. Now data became big data. We have concern about in the data science. So now If you are not having only this kind of data, you have energy data. Okay, so you are having multiple grids are available. And multiple grids continuously, all our users, we all are having the electric meters is there. Every house one electric meter will be there. Any house generating meter recordings are there. How much readings we are using per month? So average 150 units people are using. So we have to understand, we have to forecast how much unit we need to generate and how much unit is required for the users. That is the question will be there. So that will be done by earlier days by analytically, by formula or calculations. All this kind of thing you have learned. So you have learned 2 plus 2, 2 into 2 like that. Now you are using calculator. You design a calculator to do that task. Earlier days you were doing by your hand. Before that calculator was not there. If you talk about 1980s, 1985s, there was no calculator or scientific calculator. In schools we were doing normally by our hand only. So now we have replaced brain calculation with respect to calculator. Similar way we are going to change same things by using of AI. So AI is providing a tool to simulate the same way what way we are learning, what way humans are learning. That means human intelligence. So AI is the simulation of human intelligence. We are going to simulate the human intelligence. That means by inspiration of biological capability of human brain, we have created artificial brain. And then brains like Google has designed, Google Mind, Google Brain, many things Google has designed. And they have developed the applications. So we are having data in terms of image, we are having data in terms of speech. Speech is mandatory because we all are working by speaking. That means we are transferring our information through speaking. So language model also need to be created. So language model is our requirement. We need to learn various languages are there. In India there are 100 languages are there. People are talking. Then we are using language translator. Google has designed that Google Brain Mind to the Google language translator is there. So translator will translate any language to any format, but with the support of AI model. So various model has been developed. So here machine to perform the task like reasoning. So ultimately you have learned many subjects and in that subject you have answered many questions. So there was questions, how you have answered the questions. First you have studied the course and based on that course you are having the outcome. You are having the answers of that book. But once you are writing the exam, during exam there was question was asked by the examples. Like the same question will not be asked during the exam. If you are given board exam, if you are given JEE exam, any exam, the questions are unknown, unseen. Okay. So that means machine also has to answer after learning with the trained data, with the label data. Okay, so you have learned by one book, but you have answered by 5 examples, 5 questions in exam and you have cleared your course. So any course like a Maths 1, Maths 2, Maths 3, you have learned many things. Trigonometry you have studied. So first you have learned the all formulas. After that formulas, what you have learned? You have learned many questions. You have solved many problems. And exam you have just answered different unknown questions. That means you have tested out of 100 marks, you received 80 marks. So your accuracy was 80%. So likewise also machine will do same task. So reasoning is our concern, learning is our concern, and final requirement is decision making. So finally we need to take the decision, predictions. So like I give an example, in Warangal if 10 lakhs people are there, so for the grid people, how much energy need to be transmitted? How much power need to be delivered to the users? 10 lakh people are there. So how much energy required in terms of megawatt, in terms of kilowatt? They have to transmit and they have to deliver, but they have to generate. So generation will take place. So first of all, we need to collect the data. So electrical engineer people, what they are working, or different people, what they are working. Let's say example of in healthcare application. In healthcare, there are almost per day, if you are having 10 lakhs people, almost 50,000, 60,000 people were visiting to the hospitals. And 50,000, 60,000 people are undergoing about the lab test or many medical tests. So medical test, 50,000 people given the data. So many data will be collected. So it will be data in terms of Excel sheet. Like if you are getting the data in terms of total blood details will be there. Full body checkup if you are doing. So CBC will be there. Or many other components you are going to calculate related to blood. But that is blood test. Related to machine, we'll learn what is the predictions, like predictions of diabetic persons. Diabetic persons, so there are 10,000 people are suffering from diabetic from out of 20 lakhs. So we have to predict what will be the glucose level will be there. That data will be collected for fasting, after fasting, what is the range will be there, how it is varying. So we can predict in future forecasting. Let's another example, the land area of the Warangal city. We can understand, we can predict the like a price of land. Of this year what will be the price will be there, next year what will be the price will be there, after 5 years what will be the price will be there. So likewise many applications we have to develop the like AI model, and that model will be responsible to act like a human, to work like a human, to perform like a human. Okay, so that human tendency need to be involved. What human is doing? Human is thinking, human is doing reasoning, human is learning. So machine also will do the same task. So in this talk we are going to learn about what is the problem solving capabilities are there, what are the natural language processing capabilities are there. We have also language capability, we are also able to learn, we are also able to talk. So in terms of pattern recognition, so whenever we are going to design any artificial based system, in that the data will be collected and data will be realized with respect to their pattern. As I said, low level features, you have features of color, only color. So red color will responsible to identify apple as a apple, ball as a ball. But after the color, we cannot take the final decision with respect to apple and ball. We should find out some more depth, some more clearance. That means we have to learn about this pattern of the apple and pattern of the ball. That means pattern is the highest level of the features. So we have to understand about what is the pattern will be there of the ball, what is the pattern will be there. So we have to learn low level feature in terms of color, in terms of like edges, what are the edges are there, or in terms of blobs, or many other factors are there. Then medium level features or high level features, pattern or various kind of shapes, textures. So these textures also we can analyze. The textures of the ball will be different, textures of the apple will be different. By that way we will learn and then we will predict. So testing time we will show the different kind of example. Let's example in the world 200 kind of category of apples are developed. Not only our Indian apples, many countries they are developing apple. If you go Vietnam, you may get pink color apple. You may get black color apple. So by looking of black color apple, how you can realize this is apple? Only color was responsible for recognize the apple. But already you have identified the higher features. That is the texture pattern. And pattern of the black color apple also looks like a normal red color apple. So that means you can say that is apple. But you will wonder what this kind of apple category would be. Like a banana also various category of banana will be there. So like in elephants also various category of elephants will be there. Indian elephants are different. African elephants are different. So likewise if you go to the category of jaguar or cheetah, they are having different texture. So you have to recognize leopards. Leopards having various category. So leopard is not a one category. So like a tiger also having multiple category. Like a lion also having multiple category. That belongs to Asian tigers are different from the gir, or African tigers are different. From different country different tigers are there. So likewise you have to recognize only their features. Based on the features only you are able to manage them. So AI is the simulation of human intelligence. Then machine will perform the task in terms of reasoning, in terms of learning and decision making. So we can see that what is AI? So AI is a set of technology that is going to enable the computers. As of now we are going to design a machine. Machine is nothing computer. We have to design the computer, and the computer will perform the variety of advanced functions including ability to see by camera, ability to speak by mic. So we are having many sensors. By that way we are able to collect the data, and that we have to understand and translate spoken written language, analyze the data and give the recommendation. And and so on. Let's example, you are a farmer. You are doing some crop cultivation and other things. So you are doing farming. So the farmer knows many things. How to farm, what kind of crops at what time will grow. Okay, so if the farmer is doing soybean or wheat or rice, he knows in which season crop will grow. What are the impacts will come. So you are an electronics engineer, you know your insights, your problems. So likewise, farmer knows what is their problem. If you are someone is doing business of the like a land prices, so he knows when the downfall will come. What is the reason downfall will come? What are the impacts will come? So they know. So like farmers also know what is the problem will be there in crop during summer. What is the problem will be there during like a rainy season. So rainy season is a worst season for them. Manage the crop with their disease predictions also will be there. Now they are able to just deploy the sensors in agriculture, and they are going to monitor through drone. Drone consists of cameras. Camera will analyze the crop. Camera will capture the data from the crop and identify what is the problem. Any severity will be there, disease will be there, or they may provide the recommendation what kind of fertilizer can be used. That means any device if farmer will have, farmer can judge. Because farmer is judging by human judgment only, human parameter only. He cannot judge like a extraordinary judgment, because we are visualizing on eye only. So if you are a computer, if you behave like a computer, you can do multitasking. But you are a human, you can do one task. At a time, if you are preparing a chapati, you can prepare a chapati. Same time, you cannot prepare any other work. Your brain is busy for one task only. So likewise, but machine cannot do like that. Machine can do multitasking, multi-programming. That's a different thing with respect to us and human visual system. Because if you are preparing a chapati, same time you cannot do other work. If you do the chapati will come. So likewise, you can understand what we see, what we observe, what is our activity will be there. We have to perform through machine. But machine capability sometimes will surpass the computer, sometimes surpass the human. Because we can extend the limitation of humans' capability also by a machine. That is the main role of AI. So here, in other words, machines that are programmed to perform certain tasks automatically without need of human to supervise their work. Let's example, you want to drive a car, you want to learn a car. First you want to learn a car, driving. Once you will learn driving, then you will drive the car. Without learning, will you able to drive the car? No. Without learning of bicycle, will you able to drive the bicycle? So how you have learned your bicycle? You started, you fall down. Okay, many activity you carried out, 10-15 days you took and you will learn the drive. Likewise, in car driving, many people are hiring. What car drivers are doing? He just going to on the road and asking just do the activity. Then the activity is managing brain. That is the brain training. Ultimately you are doing, but your brain is learning. Your brain is learning how to use clutch, how to use brake, what speed we need to drive. All this activity that is carried out by the learning time. During learning time you have learned, and finally you have learned, you started to drive. So initial days you struggled. You have experienced many difficulties and you have faced, your car has collided somewhere, some minor or dent happened, anything happened initially. But after 1 year, you have driven around 1000 kilometers, 2000 kilometers. At that level you are learned. Same way, how much you are able to expose the data to the machine also will behave. So suppose you expose 1000 unit to the data to the machine started learn. But possibility machine may give false results also. False results also it may be given. So machine also may do the accident. Machine also may do the unwanted activity. That is the possible. But if machine will experience more and more data, that means you are able to achieve the same accuracy what we are learning after 1 year, 2 year experience. So what is the example here? What is machine learning? Learn by experience. Learn by experience. That means Machine are programmed to perform certain tasks automatically, like car will drive automatically. Data will be collected from body and will sent to doctor, and doctor will treat immediately if certain cardiac arrest will come, certain panic attack will come, certain accident took place on the road. The camera will observe, number plate will recognize and send the doctor or nearby police station, nearby ambulance will come, rescue the person automatically. Like this kind of thing is happening in European country very easily. Like in Dubai, if you go, automatic traffic monitoring systems are already there. If you drive the car more than 60-70 speed, they will catch you nearby police station immediately. Once they will just find out your number plate, immediately in your mobile phone, this message will come, you have violated speed, you will get this much fine. Or if you do violate, you have done accident, you run away from the place. But automatically in the surveillance camera, your tail will be there. They will take a picture immediately. The speed will be captured, the picture will be captured, match it like your RTO details. In India, we don't have such facility because interstate issues are there. If you go to Dubai or some other places, or Abu Dhabi, everywhere same system is there. But in India, we have 30 states with 30 systems. So the car bring from other state, if you drive here RTO no data. How will you catch them? Car you have purchased from Telangana, running in Tamil Nadu, running in Kerala, no one will catch. Pay tax here, but you are running because our system is completely not organized. The entire RTO system will be connected like you have Aadhaar card. You are going anywhere in India, your Aadhaar is working same. You may change your data through internet. If you have joined some other company, some other place, you may go and ask my address has changed. You can easily do it. So Aadhaar is universal ID. Like PAN card is universal ID. Okay. But some ID we cannot manage, like a license is not universal. The internal states. So that is a different thing. So that will manage if you are able to manage automated traffic monitoring. So what is a traffic monitoring system? Traffic monitoring only for traffic control? No. Rescue the life of the very important because yesterday I read the one article in Times of India. There are 50,000 accidents happen last 1 month in Telangana. 50,000 accidents. And if accident also there are category 2-wheeler, 3-wheeler, 4-wheeler like that. I also experienced 3 months ago one accident happened. My bone was broken. Because of one dog came on my vehicle. So sudden impact situation. Okay. So like that 50,000 accident is happening on the road. Government can reduce if entire system will be managed. So some people are unable to rescue during that time. They may die. They may lose their life also. Understand my point? So that is the one area where they can provide the sustainable development. So the thing is that how AI can be able to solve the problem. That means data will be collected from camera and everywhere surveillance camera, that is not a costly also for government. Because they may charge from users also to install one camera, it will be easily acceptable. Okay. But entire system will be connected, our entire road will be connected, they can monitor the traffic light, they can monitor the speed violation and many things. There people are not wearing the helmets also. So many things can be rescued or not. So how we can utilize the technology? We can save the life of the people or not. Another area is hospitals or medical. One of the biggest area in India. If you will see, so you are not suffering from fever from the 1 year. Everybody are suffering anytime, some fever or some disease, and they are going to the hospitals or not. And many people are facing problems for Parkinson's disease or Alzheimer's disease or any other disease, paralysis and all. And many tests are going on. Okay, and many people are getting cardiac arrest. If you go to the hospital, there are many people. 99 people are unable to save by cardiac arrest. 99, most severe. Go to the hospital, the person got cardiac arrest, cannot survive because they have limited technology. They are not given CPR to them properly. Give CPR, the technologies are there, they will save the life of the people. Suddenly, but If you rescue the life of the person within half an hour, 1 hour, we can save the life. So healthcare is a big area in sustainable development. Like energy is another area because all systems are working. So machines are going to work like a human because we are going to utilize, translate, spoken, written language, analyze data, make recommendations. So recommender system will be designed. The evaluation of AI, if you see, we can start from Alan Turing. Everybody knew about Alan Turing during World War II. He has designed one machine. He has written one code. So that Turing has proposed a test. Determine if machine can think like human or not during that time. He predicted many activity during World War. So he designed, he is the initiator, we can just, he has started to think like how machine can work like a human during that time. And he has given some code and he designed some system. So 1956 AI some point, just Joel McCarthy introduced the AI. In one conference was there, 1980 expert system. Expert system, so initially we designed the expert system by rule based. Like one example I'll give. You want to give a tip to the waiter when you are doing visit of the one hotel. What are the factors are there to give the tip? Be able to give the tip. What factors are there to give the one of the waiter will be there hotel. How much tip you will give? Best tip you will give. That is the one concept that we have designed through fuzzy logic. Fuzzy logic. That means degree of membership will be there. Fuzzy. Degree of membership means if you are a 4 feet, what will say yours? If you are a 5 feet, what will say about you? 6 feet, 7 feet, what will the range will be there? So you have only cold and hot. But hot, what do you mean by hot? Will you be able to take a bath that much hot or highest hot? Hottest. Hottest you cannot manage to bath. You are managing some temperature. So the degree of membership will be there, 50% hot, 75% hot, or 100% hot. Like a cold. Cold is 0 degree also cold. 1 degree also cold. 5 degree also cold. Minus 10 degree also cold. So you have degree of membership, that means rules are there. So you have designed one rules. I'll give the tip, the hotel is good ambience. A. Or I will give the good tip if the food is quality. Or in that case both must be compulsory, A and B. Or and C. C is another criteria. How the behavior of that person was there. So waiter has performed well, then you have increased your tip. You become happy. So out of 3, anyone will be there, it may be possible. Or out of 3 must be there, then it will be possible. Or 2 will be there, 1 will be there. That is the rule. So we started to design a machine by rule based initially. So rule based technology was there initially, the expert system. So we are going to design an expert system, rule based, for decision making. So I said I have given example tip predictions. That is decision making. You want to take the decision with the tip. Now machine, you will ask machine whether you will give good tip or not, and what cost you will give the good tip to the waiter. This is the example will be there in MATLAB toolbox in fuzzy. This example already there. So I have not taken this example from my side. This example already there. We are going to design a fuzzy system. Fuzzy system mainly based on your fuzzification, defuzzification. In between, inference systems are working based on rules. So after that, machine learning growth was started. That algorithm initially we developed like a support vector machine, neural network. They gained popularity. And 2010 deep learning. As I said, neural network was developed 2000, but it was not popular till 2010. Why? Even Google was developed 1998, but became popular why? Late 2006 or 7. Yahoo also developed early before 2000 only, but became popular. So there was Orkut was there during that time. People were making the group by Orkut. After Orkut replaced by the Facebook. Okay. But when we were there in schools and colleges, at that time 2002 or 3, Orkut was there. So likewise and we were using during that time, that one phone was, small phone was there, Nokia. Small smartphone was there. Okay? Just 1100 phone. So almost 20 crore subscribers were using during that time that phone. That era was 2006-7. Suddenly 2015 when I completed my PhD, after that, at that time I did not heard about deep learning. Now I am an expert in deep learning. 2015, so because my PhD was started 11 and I completed my PhD by 14 only. Till that, my computer memory was 2 GB RAM. And I was running the code of image forensics. My images was there 3000, 4000. And I have done training of that images through SVM, through various feature extraction technique, DCT, wavelet, Hartley, many transform I utilized. And I have done through machine learning classifier. And till that, the time was taken care at the time. 2 days, 3 days, 5 days, 10 days, sometimes 20 days also, sometimes power gone, system gone. There was no UPS facility. So 2014, when I developed, that means I completed my PhD almost done and submitted 2015 January. So till that I did not heard about deep learning. But deep learning was started 2010. But that time the computational resources was not there. And when I left to my lab, at that time the lab was having very limited computer. 2015 when I was leaving, during that time the institute has purchased around 10 computers with GPU support. And the same program I have run within 1 minute. What I learned 10 days, 15 days, 20 days, same time, because my Viva was there before 10 days I got the computer. So I just trained my model and within 1 minute I received my all models what we have is there. So this is the history what we have learned. But when I just joined NIT Warangal, I started to work in deep learning area, and whatever work I did, it became outdated. I have not done any work related to my PhD work. I did not extend because the work what I did was outdated. Like we are doing now deepfakes. The deepfake technology, I work in the same technology, image forensics. I designed one tool to decide whether image is fake, whether image is original. So I developed one tool with respect to, and I use fuzzy. That time I use ANN or HMM or SVM. These are the classifier. But till ANN I have used. CNN also was there, but I could not utilize because of memory problem. Memory crash was going on during that. Okay, anyway. So evaluation of AI, what we observed 2010, that is a deep learning. But I want to just say 2015-16 onwards, entire system replaced by GPU based. That means in the market, every institute, every technical institute has started to work with graphics processor unit. The NVIDIA came in picture. At that time I was using various boards also, embedded boards were coming. That boards like a first board I used, that is friendly ARM. It was developed by China, but that is failure board. When I purchased, I could not utilize. After that, Texas has developed Beagle board and Beagle board. It was the era of 2000 to 2010 to 15. After that, Raspberry Pi came in market. And Raspberry has captured the entire market. In 2015 to now Raspberry also going to over from the market. Now NVIDIA captured the market with GPU boards. That is Jetson Nano, one of the cheapest board with GPU support. And all now you will see, you will go to the market and you can buy normal drones also very easily. Normal drones you can buy and you can run also. Almost 20,000, 25,000 you can purchase one drone and you can do photography very easily. The room photography you can do very easily with the drones. And 2015 people were doing research. And drone cost was 2.5 lakhs. I was also having one drone. I purchased with some project support 2.5 lakhs also. So let's see how we have observed the evolutions of technology from past 10 years. As I said, after 2013, you will observe entire system will equip with internet. Even your watch already there, your phone already there. Every system, projector or this you are doing through the laptop, you will not require laptop during that time. One small gadget will come, you can just run, you can do it. And you need not require to stay here. The virtual system will be provided in your home. You can observe like physically. Okay, AI, like augmented reality, virtual reality, that will be involved. So that is the evaluation point of view. AI, how it is that has grown. Even I tell you, deep learning when it has developed the first architecture developed 1998 LeNet. You heard about LeNet architecture? It was developed 1998. But during that time, computer was not there to run that model. Understand? The model was developed, machine learning was equipped, deep learning was developed, but we were not having to run that code on that system. And first image processing code, that is IM read, that was taken around 5000 line codes. Now IM read is a one command in MATLAB and in OpenCV. But at that time, 98, 99, was written the MATLAB first command code IM read. But after that, MATLAB has converted all codes as a command. IM read, IM filter. You know IM filter? Filtering we can do. IM read, we can read the image. So various processing of image techniques converted by MATLAB in a single command. But behind that, various line of codes are. Maybe 10,000 line code, maybe 15,000 line codes in terms of Java or C++, because MATLAB has utilized with the support of Java and C++. So okay, so 2010 deep learning, so 2020 AI is everyday life. Now 2020, 4 years, 5 years ago, just we are talking AI, everyone is talking AI. So AI revolutionized the healthcare, robotics, automations and NPT. So everybody knew about automation. What are the companies are working in automations? Do you know? Siemens. Honeywell. They are one of the big people. And what are the automations? You can see. So automation we can start from cement plant or automobile plant. If you go to visit automobile plant, if you go to visit cement plant, if you go to the visit distillery plant, or if you go to visit PCB manufacturing plant. So previously 20 years ago the manufacturing was done by hand. The one PCB was designed with the hand. So people were sitting on the chip and the tables. Every tables was there. They were transferring. The PCB was required to first just finishing and then insert the. So we have to insert the pins and all. So what we have to do? Drilling. First drill, then insert the component, then solder the component, soldering, then finishing of the soldering material. Then was doing by hand. So 2005 I visited two companies. During that time that industrial visit were there in Udaipur, one of the city in Rajasthan. So two company I visited as an industrial visit. One company was manufacturing the small devices. The cost of the product was 10,000 rupees in the market. So they were doing complete process during that time by hand. And one of the company, there was one printer manufacturing company was there. They were printing, they were designing, they were manufacturing a printer. That printer will print 1 minute 10,000 pages. The cost of the printer during that time 1 lakh. I'm talking 2005 when I was in final year. So at that time I found the people who were working, the cost of the product was 10,000 by normal by hand. But at that time I have seen during the company who was working printer, the printing manufacturing of the PCB was manufactured by the machine itself, automated. During that time PLC was used. Now we are going to replace PLC in entire industry by AI. What is the purpose of PLC? Programmable logic controller. I worked 1 year under PLC as an instrumentation industry. I have done training also. So PLC, what is that? There is you are studying logics. Line of logics are there. So you are just like you want to run a motor. So what you are doing, you are using two sensors. Sensors will become some blocks are there. You just take the blocks. Blocks will connect backhand by sensors, and output will be there. So you are using AND gate. What is the purpose of AND gate? Two logics, two circuit will be there. Circuit will be normally open, normally closed. These all are normally open. Normally closed means if you have two circuit, one single bulb by two different button, they will be, one time they will become normally open, second will become normally closed. Close will become open, open will become closed, because one button will open, then second time it will close. Understand? So that is the concept will be there in industry. They were using two switches. Switches will be there, then motor will run. So there is a water level controller. There is a sensors are there, level sensors. We have to sense the level sensors and connect to the output, and motor will run, motor will on, motor will off, or buzzer will on, buzzer will off, like that. That level sensor detectors are coming. Nowadays one product is coming in the market. You can buy one level sensor kit, connect to your tanks, and you can just connect to the, then automatically when it will sense to the water flow, then buzzer will on, you will close the switch. That means your tank has filled. During that time you are sensing by water is coming out, you are saying, oh, what tank has filled, just by the observing. But nowadays we are going to automate it. So PLC and SCADA, that is a supervisory controller data acquisition system. We are talking about electrical engineering system. So how the systems are working like an automated distillery plant. Completely distillery is manufacturing on the rail. Water will fill, just packaging, cutting, everything will be taken care by machine itself. 10 people are working in that company. So when I went to that company, first company there are 200 people were there, another company there are 20 people were there. Because 1 lakh they are spending on cost of the machine. The manufacturing was paid on machine, but here they were paying to the human for manufacturing. Understand? Now automation is one of the important parts. So we are looking automation. So AI will be taken care all automated system of by 2030. Complete system will be automated. So that is the main role of AI. So it is 2020 AI is everyday life. AI revolutionize the healthcare, robotics, automation, and natural language processing. The key components of AI. So these are the keywords libraries are there. Machine learning. Learning from data to make predictions. So I want to learn from data and will make a prediction. Let's example, if you are like a postman, you want to learn. What postman is doing? Postman is only finding the pin code. There is a pin code and area code. And they were delivering the post during that time. So one of the data set created by US Postal Service, MNIS data set. Under the MNIS data set, they created number recognition, digit recognition. So digit was written by a human being. Who will write the digit? Number will be written by you. And how many people will write the digit? Multiple people. So multiple language will be there. You will write same language, I will write not same. So my way of writing A is different, your way. So when I will write 0, I will write different way. You will write 0, you will write different way. Machine has to predict 0 as a 0, 1 as a 1, 2 as a 1. So MNIS data set was created by US Postal Service, and under that 60,000 images are. And we are using particularly for testing, for developing our model. Our model is developed. One more data set has been created, that is ImageNet data. The multiple images are there for image classification, for image recognition. So you want to recognize as an aeroplane. So around 1.2 million images are there, and every object 800 classes are, 800 kind of category images are there, every object. So that means machine will be more exposing the data. So data science, we are under the data science and we are learning. So deep learning, advanced machine learning using neural network, natural language processing. AI will understand human language. You want to design a translator. To translate the human language. You are talking in Hindi, but you want to convert into Telugu by language translator. You are talking in Telugu, I want to understand in Hindi, so I will convert. So I have to understand by AI will understand through language translation that will take place. Under that, various language model need to be developed. So you are talking about ChatGPT. That thing has been built into ChatGPT. Language model is there. Data model will be there. Complete data, any kind of data can be modified through AI. So according to that, computer vision means AI will provide, just solve the problem of vision. That means how human vision systems are working, how you are a driver, I will make a robot to behave like a driver. But robot does not have sense, robot does not have other activity, so we are going to design a autonomous driving car. Autonomous driving car will sense activity on the road, so you have to extract the road, you have to identify the pedestrian on the road, you have to identify the object on the road. So all this activity will take place with the help of vision, but vision will be provided to computer, machine vision or computer vision. So that is the case will be here, expert system, that rule based system, decision making based of AI. That means you want to predict like weather forecast. How weather forecast? So you can get the 5 days weather of Warangal, you can get 5 days weather of UK, London. You are visiting London, you want to visit when rain will be there, when rain will not be there. In a particular March, you are going, you will see what is the temperature will be there in London, what is the temperature will be there in Paris, what is the temperature will be there in Beijing. Where everywhere you go, you may, because weather forecasting will be required, so based on the rules, so various sensors are equipped and identifying the nature of the weather and making the predictions. So weather predictions, or you can utilize the land price predictions or stock market predictions. So various features are there for stock market. What is the situation of stock market right now? When I should buy this particular whatever the market prices are there related to I have to buy. So I have to invest into stock market. When I should invest, I should get the right time. So that all kind of predictions will be based on the rules. Expert system. So expert system will be there. Now you are having many kind of application you are using, like you are taking the like internet service through Acta Fiber, through Hathway, through many activity. In there, they're asking your complaint. There is a one chatbot is there. Then chatbot, you are just sending your message. So human is not there, but they are sensing by human. First human. So you are writing your complaint, and they are filing your complaint and providing service, and they are informing to the humans to resolve the services. That means chatbots are working like that. So expert system is like, and robotics, AI driven automation in industry. So industry, there are many activities going on by human, but that we are going to replace the robots. Okay, so that is the key components as we are working with respect to artificial intelligence. So AI, under the AI we have machine learning, we are learning from data and learning by experience. So as I said, artificial intelligence, creating an intelligent machine, mimicking the human intelligence. So in that machine learning we are providing various algorithms, various learning methods. Now we have mainly learning methods, supervised. How we are going to learn? Another one is unsupervised. We have learned under the mechanism of supervised. We went to school, our school teacher were teaching us, they were writing on the board, they were dictating in the class, we were noting down, and after that we were going to back, we were doing some homework, we were learning, this mechanism was going on, and finally we were writing exam. That means we were there under the supervision of teacher. We were learning by the teacher, we were learning by book, and they were teaching us that book what has written. So they were opening the book, they were reading the story, they were making understandable about the story, and after that by the unseen questions you were writing exam. That was tendency was there, like a same mechanism we are going to machine. So algorithms that enable the computer to learn from data, learn from book. So you have learned from the book or various activity, you have learned cricket by activity, to play the cricket on the ground. You have learned bicycle, just drive the bicycle on the ground. You will learn. After learning, now you are able to try your bicycle. You have already learned, your brain has understood entirely whatever the concept of driving is there. Same thing, computational models. That means like a human brain, completely processing units are created like an artificial neural network. So in that neural network, and depth of the neural network has increased by deep neural network. That is neural network with multiple layers. And for hierarchical representation learning, that means multiple layers which consist of many processing nodes, processing units, which are going to extract the features and going to solve the problem and make the predictions as per the artificial neural network. So what is machine learning? So machine learning is a subset of AI, enables the computer to learn from data without explicit program. Key features: learning from the data, so learning in pattern. You have to learn about pattern, you have to learn features. So improve the accuracy over time. That means learn by experience. By the time, accuracy will improve. Like I said, if you drive the car 10 years, you will be expert. If you write a programmer, or if you will be programmer for machine learning for 5 years, you will be completely expert. But if you started machine learning, you are a beginner. Okay, that means more mistake will take place when you are a beginner. When you are intermediate, little mistake will take place. But if you are expert, very few mistake will take place. Understand? So accuracy will improve. That means you are learning by experience. Improve the accuracy over time. Used for automation, used for predictions. Example, machine learning. Or you are getting many messages. So what message will go to inbox? What message will go to spam? Spam filtering will be there. Automated program will be there in Google, in Gmail, or various other mails you are using. Or recommending the systems, or self-driving car, autonomous driving car. So these are the concerns we have. So machine learning is a part of, that is AI, how we are going to learn. So we can compare machine learning versus deep learning about data. They are having multiple data. So volume of data is increasing. So we are varying about data volumes. Or machine learning, thousands of data will be there. I said in my research work around 2000, 3000 data was there. Now in deep learning, big data. Data became big. So millions of data points are available now. We are able to extract, like this recording is going on. It will become around 300 GB data. It will become 300 GB data. So likewise, if 5 program will be there, how much data will be there? Where will store this data? So likewise, this numerical value like classification or score, or how it works. So working point of view, we are using various type of automated algorithms. Machine learning algorithms are responsible, learn to model functions and predict the functions and provide the actions from the data. Finally, how it's managed. So algorithms are directed by data analysis to examine the specific variable in data set. What are the specific variable will be there? What are the performance measures are there? Based on that, we are going to manage. Finally, the deep learning, this thing will change by neural network. Neural network is a cascade of multiple layers, and neural network pass the data through the many processing layers. Many layers will be increased, and to interpret the data with features, and their relationship of the features will be there. And many algorithms are applied here. That will be the self-directed to data analysis, and they put into the productions. Finally, the output will be started to identify. So, what is the role of data in machine learning? Data is very important because various sources are the data will be generated. You can keep the surveillance camera at road, data will be started to generate. You can keep your surveillance camera at your building, data will be started to generate. So, every day 24 hours camera will monitor. Data will be generated. So like that, data will generate from various sources: structured data, organized data, unstructured data, semi-structured data, or garbage in, garbage out. Poor quality data, that is the inaccurate prediction. So we can say data is the foundation part for machine learning. Without data, we cannot do anything with machine learning. So more data lead to more predictions. If you expose more about more data, your prediction will be very accurate. As per the timeline, also you have to learn more. So time will take more to learn about data, because if data is huge, it will take more time for training. Training will not complete within that hour. It will take 2 or 3 or it may take 10 days also, depending on the data, characteristics of data. So we have to understand about the characteristics of data. So types of data: structured data like database, spreadsheets, or unstructured data like images, text, audio, or semi means XML files are there, or different other files are there. So we are going to just concern about what is the role of data. So we are having data, we are going to train to the machine, then we are going to build a model, develop a model, and then we are going to predict the outcome. This model will install to the outcome. Like you have trained one machine to understand what are the objects are there on the road. That means just identify the object detection on the road, and then you will install that code to the on the road. Just like you have installed one machine, and that model will be built there. Already previously you have trained on few examples. You are going to just install into the real-time activity. That means prediction, and prediction will tell maybe positive result will come or maybe some false result will come. That means it should expose more data. That means suppose if you are not able to get correct output, then you have to train some more data. So if you expose more data, if you train on more data, you may get more accuracy, and all the time your accuracy will increase. Benefits point of view: automation, efficiency, enhance the decision making capability, personalization. So AI provide the various recommendations. AI will provide the predictive analytics. We can forecast in terms of healthcare. As I said, 50,000 accidents took place last 1 month in that particular place. We can reduce the accident in particular area. That predictions we can reduce. With respect to, we can provide the activity. Finance, power system. As I said, power system, power consumption is our requirement. How much power is consuming in particular area? Can we reduce the power? Can we increase the power delivery? All these kind of factor will be calculated by using of predictive analytics. Similarly, improve the security, cyber security. Various frauds are going on every day nowadays. Government has started to, before call, they are saying, because many fraud happened with people. They call, I am from CBI, your passport was utilized, your Aadhaar was utilized, and they cheated many people. So finally government got this information, crore rupees has taken by the people. After that they started to inform you, don't believe on any call. They are saying your father is having accident and he is in hospital, pay 10,000, pay 1 lakh, 2 lakh, like that many call, they did it and they cheated. So fraud predictions will take place. Even by one button, entire amount of the money gone. By single button. So like that, there are many cyber security issues are there. That is another factor of sustainable development. Otherwise, either you have to close the UPI and use for cash transaction only. So if you want to save, you can say that some people are saying I am not using online banking, I am not using online. But where you will stop? Entire people are using now online. People don't have changes. Your 1 rupee task people were giving earlier days toffee. Now what toffee? They cannot give toffee, they will eat only. So likewise you are saving yourself by using of UPI. So UPI is not a safe. Definitely it will be safe once you provide the powered algorithm, fraud detections and cyber security. So these are the benefits are there. That means we can reduce the manual efforts for particular repetitive tasks, enhance the particular decision making capability. So AI driven insights improve the accuracy and AI tailors recommendation. So all are using OTT nowadays. You are watching movies on Netflix. Many movies are coming automatically on the screen and you have started to watch. If they will not recommend, you won't watch. Just bet it. Just they are showing trailer also. Just one trailer will come, you will see, okay, you will get interest, okay, let's watch. So you started watch. So likewise, 90% people are buying the product from Amazon by only recommendations. Do you believe you started to search anything? Like you started to buy one ticket from Make My Trip and 3-4 times hitting you have done, they will increase the price. They got in the information, someone is hitting it, they are going to buy. Just 5 days, 6 days, just hit it, the same cost of the price, 5,000 will become 7,000. And after some time, they will reduce it. Understand? Because recommendations they are getting, they are having search engine by AI, they are finding, they are predicting. So likewise, you are using Netflix, you are using Amazon, you are using Flipkart or many things. You are like that, your personalization. So there are AI tailored recommendations are providing through these services, that is using the AI. So these are the benefits in terms of enhance the analysis and insight, improve the healthcare services and automation of repetitive tasks. There are many tasks are happening related to automation. So one of the most impactful benefit for artificial intelligence ability to perform automated, and there is a improved healthcare services. So AI is one of the revolutions in healthcare industry by improving the diagnostic accuracy. As we have seen CT scan, as we have seen MRI scans, or many scans are there. So how to improve the diagnostic accuracy? That means by using of various machine learning and develop the many models to recognize the early disease predictions. We have to predict the early disease, like a Parkinson disease is there, or like Alzheimer disease will be there. If you predict in early stages, or like cancer detection will be there. Or sometimes cancerous area may be classified in terms of non-cancerous. That means in terms of malignant, in terms of benign. So various factors are there. So we have to improve the diagnostic accuracy or treatment effectiveness. So machine learning algorithm can analyze the medical images such as MRI images, CT scan images, or enhance the data analysis. That means all assets, that processing of analyzing of large volume of data quickly. That means it will provide the result very fast. Traditional data analysis methods can be time consuming. So time was taking too much during that time. Like example, nowadays there are many universities they are using by using of like question paper will be online, the result will be online, corrections will be online, anything will be online. So people are correcting very fast and result will come very early. Like 10 years ago, 15 years ago, when we were studying, the board exam result was taking 3 months, 4 months during that time, and you were sending the paper and taking time to review for 1 year, 1.5 years. It was time consuming. Now because of internet system, because of computer system, became automated, because entire chatbot system became very strong because of AI analytics. So data analysis one of the important part, and healthcare improvement. As we have seen today, if you go to the hospital, you can observe various machines, very advanced machines are there. 10 years ago, X-ray machine was different. Now current X-ray machine, 360-degree X-ray machine. You can scan anywhere, any position you may get, and that can print, and accuracy. So accuracy improvement will be there. Analysis part will change, and automation. So various tasks with respect to automations, we are getting more accurate output, and multiple tasks that will be completed, or repetitive tasks that will be completed very fast. So challenges also, that is one of the pros and cons part will be there. So data privacy security, because of ethical concern about personal data uses, maybe possible people can use their data. Bias, the AI can reflect human biases in data. High computation cost. As I said, computation cost is not a barrier, but definitely you have to pay. Like Google Colab you are using, you have to pay. So deep learning models act as a black boxes. Lack of explainability. We cannot concern about final explanation, like a black box. Black box means we don't know what parameter we need to fix, what are the layers we need to fix, what are the parameter we can modify, hyperparameter we have to modify. All are hit and trial or prediction. That means completely it's a lack of explanatory and ethical concern. And AI replacing human jobs, but decision making risk also. So these are the certain challenges are there. With respect to AI, if you see, these are the particular applications we can visualize related to data management. Data management concerns network security, or like a privacy, access, ownership, and all we are using financial, like in terms of banking. So data is our concern, because we are using money in the bank. So how much we are secure with respect to our financial condition. So concern are about the organization, data set. So related to data set, insufficient data will be there, sometimes imbalanced data will be there, or poor quality data will be there. So we have to concern about data set first. That is our first requirement. Then we have to concern about what kind of algorithm will work with respect to various data. So model type selection. Sometimes a model may overfit, will not provide perfect accuracy. It will take too much time for training and output will not be received. Overfitting, underfitting, and also require hardware resources. We want to go, what are the hardware capabilities are there. That is the main limitation, that we require GPU based system, we require high-end workstations. So all are the requirements, software also, and particularly project management. So that is the talent pools. Hot job market, competition for skilled AI worker. That means completely jobs are available, but depend on the how skilled people are there in AI. And fifth one, project management. So communication gaps as well as some problematic expectations are there among the various departments. And finally, we have to understand about security, privacy, ownership across the organizations. So these are the certain points are there. So limitations always are required, but the application market is very huge. That means if you see the market of AI, we can visualize here healthcare, gaming market, financial market, social media. So you can see social media, Instagram. How much people are using Instagram? How much people are using WhatsApp? How much people are using Facebook? And many other social media is there. Twitter is there. So likewise, travel also one of the component. There AI is going to improve that capability. Like a ticket booking you are doing. So it has been changed very greatly from the past 5 years. This is where we are using AI, material design. So we are going to find out which material will provide the best accuracy. So all material findings with respect to metallurgical cases, e-commerce, all these are the applications we can, but we have more applications as compared to the real world of AI. Like if you see the real world conditions of AI is provided various conditions related to like cancer detection, medical imaging, or I said telemedicine. Telemedicine is one of the area where we can see the various sensors which equip with the body with respect to smart gadgets and with respect to variable sensors, and we can monitor the body health continuously and connect to the doctors, as well as finance, that is fraud detection, stock market prediction. I said autonomous vehicle, already I said AI powered self-driving car, smart assistant. Smart assistant all are using AC, or we are using many gadgets related to Alexa, related to Google Assistant, Siri, power system. So AI is helping nowadays for energy forecasting, grid optimization. As I said, power consumptions are increasing day by day because components are increasing. Gadgets are increasing, devices are increasing. Previously, limited people having laptop. Now everyone having laptop, everyone having mobile phone, everyone having some tablets. So likewise, and having like smart watch, and some more device will come in the market. So power requirement will increase. So we have to optimize the grid power requirement. All this can be done with the help of AI. So real world applications, these are the real world area will be there. Now, in terms of machine learning, the machine learning subset of AI, and there are learning methods are there. That means we have to design various algorithms, various technique for a particular predictions or decision making with the help of data. Now, data is available in terms of label. That means you are going to the market and finding the tea. So tea has written, this is the tea of Tata, this is the tea of this company. So that label will be there. So you are going to design a system, that system must have label data. So you are going to predict by training. But unsupervised learning, there is a no data, no label hidden. So by the pattern recognition, by the clustering, you are going to realize the output. So find the hidden pattern. And one more learning method is there, that is called reward based learning. That is learn by interacting with the environment through reward or through penalties. So like a feedback system. By that way we are going to learn this technology. Now in terms of machine learning, predict the next value, task driven. In terms of unsupervised learning, data driven. So this is the task driven, this is the data driven because we don't know exact label of data, and this is the learn from mistakes. We are learning by mistakes. So in all three learning, one mechanism will work task driven, one mechanism will work data driven, and one mechanism will work learn by the mistake. So we can compare supervised learning, that means an outcome will be there. We have input, we have outcome. We have to match with your predicted output with accurate outcome. Here no outcome information. You just have to predict the outcome. So here find the pattern that relate to outcome. We have to match that outcome and use the pattern for predict the outcome not yet known. And here no outcome is there. Analyze the or identify the group. That means we are going to identify by one group of the similarity. By the similarity mechanism we are going to make the output. Without any label, without any human support, without any supervisor. So no supervisor will work. offer insight into characteristics that define the groups. So some group people are having same characteristic, will say this is the output. Some of the group will have some kind of characteristic, will say this is the output. So like we are going to identify by clustering. So we have various mechanisms like clustering techniques we are using, like top-down design or bottom-up design. So divide the work into small work, and based on the similarity, groups of the similarity, we are going to cluster them. We are going to identify them. Likewise, in terms of reinforcement learning, make a decision based on the trial and error. We are getting error, just change. We are getting error, so by mistakes we are learning. So here decision making algorithm constantly refined based on the rewards. If mistake will be done, mistakes will be penalized. Output will come, rewarded. So likewise, this mechanism will utilize excels in complex situations. We are going to become more and more excellent in the complex situations with the help of all these three categories. So there is a 5 minutes break. I will continue just half more. Even these are the data will be there. These are the labels will be there. We are going to design a model. Now model will be trained, and we are going to just once completed, training will over. Then we are going to test and we are going to predict. So these are the output with label will be there, and we are going to match. So that procedure we are going to follow here. So here there is a relationship between input features. So we are going to map that feature with corresponding label. If you are not reaching to that label, that is considered as an error. So finally, by using of training methods, we are going to minimize the error. Once we reach zero error, that means your exact output and your predicted output will be matched. Both will be equal, then we'll reach zero error. So that is the procedure we'll follow. So model makes predictions based on the pattern available in training data. So data will be available with their labels, and output is just we have designed the model, and that model will be able to determine the label. So finally, once you have trained the model, that model will be utilized to identify that whatever the label will be there. So that means with the label we are training the machine, and finally with that trained model will be utilized to predict the label only. The final label will be identified. So here model will make the multiple predictions based on the pattern is available in training data and improve the accuracy. So initially we have trained 10,000 data, then we increase 20,000 to 30,000, and we are going to test the model with unseen data only. So finally, if unseen data will provide the accuracy 98-99%, that means we have approved the just acquired just like a required accuracy. So classification, various tasks we are doing, like we are going to classify in terms of binary, and we are going to classify in terms of continuous. If you have continuous output, you can do the regression. If you have binary output, yes, no, true, false, 0, 1. So like you want to classify either that image consists of cancer or not a cancer. Like that, this task will be done by the classification. So we have multiple applications, spam detections, fraud detections, and medical diagnosis. With various medical diagnosis we are doing related to available data, we are going to utilize either classification model or either regression model. So in the supervised learning, we have linear regressions. So linear regression is used to identify relationship between continuous dependent variable and one or more independent variable. This task is particularly useful for predictions about future outcome. And linear regression expresses the relationship between variable as a straight line. That means we are going to map the value on that straight line, and when there is a one independent variable will be there and one dependent variable will be there, it's known as simple linear regression. And under the number of independent variable will increase, then technique will referred as a multiple linear regression. Likewise, we have logistic regression. There is another type of regression. Under that, you can handle the categorical dependent variable. When they are having the binary output, it will consider as a true or false, positive or negative, or yes or no. So likewise, this is the model we are going to map on this line. This is the like we are going to map. So related to weight and height, we have classified. Similarly, this will become a logistic regression. So the points will arrive on this model. It is obey, that is non-obvious. So related to another technique, we'll see that decision tree classifier. So the classes will be identified in terms of tree manner. This is the decision. We are going to take the decision either this direction, either this direction, or either this direction, or we may go. So it will look like a tree, and it is supervised learning methods. Then data will be splitted with respect to branches based on the feature variable and forming a tree-like structure where each node represent as a decision. So this decision, no, we can reach by this way. This decision we can reach by this way. This decision we can reach by this way. This decision. So there are 4 decisions will be possible by one tree node. Likewise, we have random forest methods. The random forest methods that we are using the multiple trees. The random forest is a collection of decision trees and working together and make the predictions. So this is the finally we are getting the majority voting or average voting based on the final result. So result will improve. So one more popular classifier is there, support vector machine. So basically support vector machine classifier is working to draw the hyperplane. So with respect to hyperplane, we draw the positive hyperplane and negative hyperplane. So based on that, we are going to separate. So SVM basically support vector machine is the particular separate the classes of data points. So various classes are there based on the decision boundary. That boundary is considered as a hyperplane. So by using a hyperplane, we will consider 2 data points are there. So one single line is enough to separate the data. If we have 3 data points, so 2 different lines will be utilized. If we have 4 data points, so 4 different lines will be utilized to separate them. So likewise, the goal of SVM is find the optimal hyperplane. Then the value can data point can be separated. Then we are going to maximize the margin that will between classes in data set. So the aim of this classifier is to achieve the separation of data. So we have separated this line. So these people are one class, these people are another class, and one more class. So that will consider as a outlier because only 1 points are there. We cannot consider here. So we can neglect this point. So only 2 classes are in. So likewise, outlier will be neglected. So like these conditions, we are going to draw the best hyperplane. So hyperplane is the best separation. So these points are separated by this line, these points are separated by this line, and this red point separated by this. Separating with respect to different classes will be obtained. So support vector machine used for data classification or regression. Both tasks we can do. It's a very popular classifier. So neural network also will be the part of supervised learning. Neural network consists of powerful model for suppose to do the task of supervised learning task and making the map conditions input versus desired output. Structure, there are multiple layers will be there. Input layer, hidden layers, output layers. So likewise input and output will be multiple. This is the shallow network. If you increase more than 5-6 layers, it will become deep neural networks. So likewise, hidden layer task with complex transformation. In each node is the processing units, and they are responsible to extract the features. So these layers, so every layer multiple features will be extracted and will predict the final prediction, the output prediction. So that is called artificial neural network. Application, same classification, image classification, image recognition, or speech recognition, speech classification, any task or regression task. Advantage point of view, we can capture the complex relationship in large data set. So this is the neural network as we can utilize same for supervised learning. Now overfitting, underfitting problem. So we can observe by this line, this is underfitting. So overfitting, we are unable to perfectly manage the separations. That is the case here. Perfectly we have managed by straight line, that is linearly separable, but this is not linearly separable. So overfit model perform well on training data but poorly on new data. That will not be able to show the output on new data and causes complex model or insufficient training data or imbalanced data. These are the reasons would be there. Solution, we can regularize the architecture, we can reduce the model complexity, we have to provide the cross validations. So multiple validation technique will be there. Underfitting model is very simple, capture underlying patterns, causes its insufficient training. We have not done properly training or overly simple model we have utilized. So solution, increase the model complexity, sometimes use more layers, more number of feature extension. So this is the more data, or we have to increase the data, more training will be required. That is more longer time we have to train the model. The goal is balance complexity, achieve the generalization. So we have to manage the complexity versus data balancing condition, then it will reach to the output. So whenever we are going to evaluate the model, various performance measures are responsible to validate the output. So validation will take place either in terms of only one parameter accuracy, but we cannot rely accuracy because many times many parameters will be responsible to identify the false data also, false predictions also. So we have to predict the false. So it measures overall correctness. That means overall you have achieved the correctness, you can say accuracy. So limitation, it will mislead the imbalanced data set. So accuracy means total number of correct predictions by the total number of input samples. But we have to consider about precision recall, and both are inversely to each other. So measure the proportion of true positive out of all predicted positives. So total 100 predictors are there. How many positives are there? So important when false positive need to be minimized. So we want to reduce the false positive. If it will reduce, automatically precision will increase. So precision will depend on false positive. TP by TP plus FP. Another parameter is recall. Recall will measure the proportion of actual positively correct identification. That means how many you have correctly identified. That is the depend on false negative are very costly. So important when this is very costly. So we have to avoid this one. And F1 score, that is called harmonic mean. That means because of precision recall. So precision will increase, so recall will decrease. So we have to make balance between them. So according to the use cases, balance precision recall, especially when you have imbalanced data. That is 2 into precision recall by precision plus recall. That is considered as a harmonic mean. Finally, we have to compute the confusion matrix. Confusion matrix nothing. Table summarize the classification report. So classification report will be generated. So that is true positive in case where predicted yes and real output was also yes. But true negative in case where we predicted no but real output was also no. And false positive in this case where we have predicted yes but actual was no. And negative where predicted was no but actual output was yes. True positive, true negative, false positive, false negative. Based on that, we will create this is considered. So accuracy F1 score will be computed, negative rate, precision, recall and specificity, and this is the actual. True negative and false true positive, this is our concern. So AUC based on this area under the ROC curve will obtain, that is the how much plot will tell positive rate, that is recall or false positive rate versus one graph will be drawn. So we have to compute the AUC. So it will measure the how to distinguish the particular classes. That classes will be correctly classified or not, that will be identified by the AUC. So measure the model's ability to distinguish yes there is a yes and no yes. That is the requirement. So here range 0.5, that is randomly case will be there and perfect classification 1. And interpretation AUC 1 perfect model. 90% excellent performance, 50% not better than, that is the random gauging. So use cases, it's ideal for imbalanced data set or binary classification problem. In that case, it is very helpful. So what is unsupervised learning? That means this is the structure will be there. You have to just grouping them with respect to just similarity. So similarity of this will be one group.
Similarity of this. So machine learning approach where model is trained using unlabeled data. We don't have label. Unsupervised learning methods are tasked with finding the patterns, finding the relationship within the data without any prior knowledge of data meaning. We don't know what is the meaning of data will be there. So training model has only input parameter, no label, no exact output, and discover the output, discover the pattern by the method, by the technique. So it is used for clustering. You have to cluster or dimension reductions like PCA, ICA, and market segmentations, anomaly detections, and recommendation system. These are the tasks will be based on unlabeled data that will be solved by the unsupervised learning. So we have the like method. We are using k-means clustering. So we have to choose the centroid based clustering. We'll find out the centroid of any point and we'll see the distance between this point and merge them. So using k equal to 2. So this algorithms will find out the centroid. Based on that, partition the data into k number of clusters. So we have done 2 cluster only by using of this. We are going to minimize the variance within the cluster. So within the same group, we are computing the variance. The variance will be minimum. This will be the same group. Variance will be maximum out of that group. So algorithm finally will produce the clustered output. It's different 2 category has been classified or grouped. So principal component analysis also comes under the same category that is required for dimension reduction. So PCA is a method we are using mostly under the unsupervised learning method. So it's a technique that transforms the correlated features which are very, so we have multiple features but which are coming under that line or this direction or that direction. So it's a principal component 1, principal component of 2 which are more important like a phase detection we are doing. So on the phase various features are there, but we are finding the after PCA principal feature component will be expected that will be recognized based on that phase. So out of 100 we found 20 principal components. So we have reduced the dimension and reduced the computational complexity also, and we have correctly classified or recognized the phase. So that is the main important part. So dimension reduction technique comes under the unsupervised learning. So it's a transform the correlated features which are mainly correlated to your phase like that into a set of uncorrelated principal component to capture the maximum variance. This direction and that direction will be the more variance condition will be there. Based on that we are going to identify. Now another technique is autoencoder. Autoencoder, it's a series of neural network that is we are using. So these are the multiple layers deep neural network we have created. So encoder will encode. These are the local representation, and finally we are going to create the multiple layer and decode and produce the output. That is called autoencoder, transformer. So like the type of neural network is used for representation learning. Especially we are going to compress and reconstruct. Like a image compression we are doing. In image compression, how we are doing? We are just using the transform. We are just reducing the dimension. That means by reduction of redundancy. So finally we are going to compress the data, and later on we are going to recover. That is reconstruction. So reconstruction means just first stage we have compressed the data, and then next stage by decoder we have to extract. That means reconstruct the data, and we have to calculate the value. What is the value? Input and reconstruct it. That will be calculated by mean square error, and mean square error will tell if error is very low, that means you have correctly classified, you have correctly decompressed the data or recover the data. If your mean square error will be high, that means you have reduced the more information. So more depth information has lost, and PSNR also another parameter. That means peak signal, how much noise will be there. So encoder and decoder is basically compression and reconstruction of the images or any information. That will be done by this method, autoencoder. Autoencoder used for the representation learning, which compress and reconstruct the data to capture the important pattern without any supervision. Reinforcement learning, it's
one kind of methodology we are using with respect to agent, connected environment, that will be rewarded. So like actions will change based on the whatever the reward will be given. So machine learning approach where agent will learn by predicting that output will be correctly identified or not. If you not identify, go back and change the output. So interacting with the environment through the reward. So again, this environment. So like agent takes the actions. Agent will take the actions and environment will respond. And agent will learn from the either reward or either by penalty. So according to that, it is useful for decision making in dynamic environment, robotics or self-driving car or AI game playing. All these are the examples works under the reinforcement learning. So components which are required: agent, learner or decision maker must be required here. Environment, that system that agent interact. How agent will interact, that system is required. Actions, so action will choices available to agent. If suppose this output not happen, what agent should take the action? That choices must be given, or reward or penalty. So feedback, that is the feedback mechanism will be given for learning for best actions. Finally, policies also need to be framed. So strategy for decision making and value function. So it will measure the long-term rewards of steps. So I'll stop here. Remaining part I'll continue in the tutorial sessions. That will be there related to how to utilize at practical level. So deep learning is also advanced part for machine learning neural network. So we also have seen a neural network. Neural network consists of input layer, hidden layer, output layer. So basically we are going to increase the more than 5 layer, 6 layer, it will become deep neural network. So basically it is utilized for recognition, NLP, speech recognition or autonomous system. That's all.
Thank you so much, sir, for your intro towards machine learning and deep learning. And thank you, dear participants. So we are done with our day 1. So snacks are available outside. So and tomorrow again your session will start at 10 o'clock morning. So same venue here you need to join at quarter to 10 like that. Morning we have 2 sessions and afternoon again 2 to 4 we have hands-on session in EC department labs. So and whoever did not carry their hostel registration process we can do now.